Hey my NEET warriors, welcome to the oscillation sessions. I know you were all waiting for this session and I was reading all your comments regarding which topic you wanted next, and thanks to all of you that since you are spamming in the comments, sir, we want oscillations, waves and SHM. So here we bring to you in the Super 6 series, which is targeting 700 plus scores for even a below average student. And yes, in today's one short session, we are going to do the NCERT questions. We are going to go through the main things which are there in the NCERT, as well as we are going to do PYQs. So it's a complete chapter with me, your Captain Shreyas. I hope I'm audible and visible to all of you. Hello, funny family. Suresh, welcome. Madhumita, Malkodi. I was seeing Madhumita, your comments also on Telegram that you are all waiting. Hello, Sarath. Nice to see you back. Hello, Krishna. So yesterday's class also, you are full with Josh. Good evening, Tejo. Hello, NEET aspirants. I hope I have started, and am I audible, visible? Please let me know. Please let me know in the chat box. Yes, looks like I am. Yes. Great. WP. Yes. Good evening, Kashish. Hello, Teju. Let's begin with the lecture. Those of you who do not know me, I am your Captain Shreyas, your physics master teacher, training kids for more than a decade, sending kids to all the top-notch colleges like AIMS, AIMS, AFMC and all of that. So here we are today so that this year too you enter the top-notch colleges in the country. Yes, audible, visible, perfect, Sarath. So let's begin with the class. And let me also remind you, this Sunday there is going to be a weekly mock test as well, apart from your victory mock test, which is at 2 o'clock. So victory mock test at 2 o'clock, weekly mock test at 9 o'clock. So both the tests are available for all of you at absolutely free of cost. So make sure you are a part of it as well. Now, this chapter mainly deals with oscillating periodic motions. So let's first of all understand why you need to study this chapter, and also what's the difference between periodic motion and oscillatory motion. Okay, you will see this chapter is very closely related to waves. Look at this pendulum which is going back and forth. It's going back and forth. Some kind of wavy pattern is formed. Look at this masses connected to the spring. It's going up and down, and you can see a wave like structure. So probably this tells you why you should study this chapter first before studying waves. I have seen many students in 12th standard also, they study light waves or electromagnetic waves without studying the 11th standard chapter of oscillations. So my dear students, my humble request, please watch this lecture first before seeing any of these chapters, be it waves, be it AC, be it electromagnetic waves or light waves. If you are studying alternating current, light waves, then please study oscillations first, SHM first, then go to these chapters. You will see that it is very easy. Okay, that's number one. Now, what's the difference between oscillatory and periodic motion, and is it possible something is oscillatory but not periodic, and vice versa? Let's have a look at it. So if I take a set of motion, in which few things are like oscillatory, and if I take a set of motion which is like periodic in nature, you will see some things are common between them. That means they are both oscillatory as well as periodic. So this is the part which is basically it is oscillatory and periodic. And anything outside of this is neither oscillatory nor periodic. So if something is outside of this, it is neither oscillatory nor periodic. Let's understand it with examples. You will never ever be confused. Is there an example where something is not oscillating, something is not even periodic? Best example is projectile motion. You throw something at an angle, it goes up and down, it is not repeating itself. That's why it is not periodic. It just goes and falls, that's it, it's not going to repeat. So that's why it is not periodic. Is it oscillating? That means, is it going there and again coming back? Is it going there and again coming back? Is it to and fro? No. So it is not even oscillating. So hence, such a motion, I would call it as neither periodic nor oscillating. So example for that is projectile motion. Projectile motion. So projectile motion, right? Projectile motion is a very good example. A Pandu walking towards Champa's house is also an example of, neither oscillating nor periodic motion. Is that right? Yes. NEET aspirant, this lecture is going to be easily 2 hours to 3 hours. We are going to cover this lecture in detail. Next important thing. Can you think of an example which is purely periodic, but it is not oscillating? Purely periodic, but it is not oscillating. Best example, moon going around the earth. Every 28 days, it completes one revolution, but it does not go like this, then like this, like this, then like this. So it is only going in one direction, it is not turning around. So the best example will be the revolution of the moon, which takes around 28 days. Which takes around 28 days. Is that right? That is purely periodic. It repeats itself. Yes, clock motion. It is periodic. Every 1 hour the hands would have gone, the minute hand would have gone, or every 60 seconds the seconds hand would have completed one revolution. Is there an sorry. Is there an example of just oscillating motion? Definitely. When you're tensed before your exam, you walk like this, then you go like this, then you get something, you'll pick a chips packet, you'll eat something, and then again you'll come back. Then you will remember, oh my god, I forgot this. Okay, let me see this. Oh wait, I think I have kept my pen there. Let me get back over there. So you're going to and fro. So that is a very good example of oscillation. Very good example of oscillation. So to and fro motion, any kind of to and fro motion, back and forth motion is a oscillatory motion. Is that right? Very good. Even electron around the nucleus, Sanvi, yes, that is a periodic motion, definitely. What about oscillating and periodic? Meaning, not only does it go to and fro, but also it takes the same time after every oscillation. So if I went here and came back in 3 seconds, then next time also I should take 3 seconds to go and come back. Again I should take 3 seconds to go and come back. If sometimes I take 3, sometimes I take 5, sometimes I take 2, then it is not periodic in nature. Yes, the best example of such oscillating and periodic motion is a pendulum. Are you able to understand the difference, my dear warriors? So can I then say that whenever you are talking about periodic motion means the motion repeats after a fixed time interval. After a fixed time interval. That fixed time interval is also called as time period. Time period is basically the time after which the motion repeats itself. The time after which your motion repeats itself. Can you give me an example of time period? Yes, definitely. Why not? What is the time period of the second hand of a clock? The second hand of a clock, it completes one revolution after how many seconds? 60 seconds. So 60 seconds is the time period. The time period of the revolution of the earth around the sun, around the sun. Yes, what is it? It is 365 days. So after 365 days, it will repeat itself approximately, and continuously it will keep on doing the same things again and again and again every year. That's why you celebrate your birthday every year. Very good. Yes, definitely, definitely. Now, if I take the reciprocal of the time period, I get a quantity called as the frequency. So frequency is nothing but how frequently you are doing it. The symbol for that in physics is usually F. It's how many times per unit time. Say for example, you know, Pandu visits Champa's house ten times every 2 hours. He misses Champa. That's why he's visiting Champa's house 10 times every 2 hours. So what is the frequency, my dear warriors? Think about it. 10 number of times every 2 hours. So 10 times he's visiting every 2 hours. So 10 by 2 is basically, it is 5 times an hour. He is visiting it 5 times an hour. Every unit of time here is hour. He is visiting 5 times. So that is basically the frequency of Pandu per hour. That is the frequency of the Pandu per hour. Is that right, everybody? Now usually the unit of frequency is hertz. So frequency, the usual unit is hertz, and the formula for frequency is 1 by time period. 1 by the time period. This is the formula for frequency, and the unit is in hertz. The unit is hertz, Hz, and 1 hertz is basically second inverse. So say for example, if I tell you the frequency is 10 hertz, that means 1 by time period is 10. That means time period is 1 by 10. That means the time period 1 by 10, which is 0.1 of a second. So in one oscillation, or for one revolution, or for one complete motion, you are taking 0.1 second. So in 1 second, you will do 10 such things. If you take 0.1 second to complete one event, so you will do that event 10 number of times in 1 second. So that's why the frequency in this example was 10 hertz. That's why the frequency in this example was 10 hertz. Is that clear, my dear warriors? So if you know frequency, you can find time period. If you know time period, you can find frequency as well. Like in this case also, if I do 1 by f, I will get the time. If I do 1 by f, I will get the time. So if I want to find the time, I will just do 1 by f, which is basically 1 by 5. So this will be nothing but 0.2 hours. 0.2 hours. So for him, Pandu, to visit Champa's house, every time it takes 0.2 hours. Every 0.2 hours he is visiting Champa's house. So in 1 hour, 0.2 will come 5 times. So he will visit 5 times in 1 hour. Is that understood? Give me a thumbs up. Is this understood? Give me a thumbs up. The clear-cut knowledge of what is frequency, what is the meaning of periodic motion, and what is the time period, of any revolution or oscillation or any repeating quantity. Is this much part clear, my dear students? Is this much part clear, my dear warriors? Very good. Now in this, so I have put up some slides also, printed slides as well, just in case you want to have some nice, written content as well. So we saw about periodic motion. Here I will also define oscillating motion. Oscillatory motion, my dear students, oscillatory motion is basically the to and fro motion. To and fro, back and forth, going and coming, repeating, but you are going and coming back. That is basically your oscillatory motion, okay? And a motion which repeats itself after regular time intervals is called as periodic motion. Is called as periodic motion. One such good example of periodic motion is your ECG signals. Have you seen doctor putting those electrodes on the body and then measuring ECG? Everybody, you might have seen some tuck 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 tuck, one graph will come. How many of you seen that graph, my dear students? How many of you seen that graph? Like this it will come, then like this it will go, right? That is also a periodic motion. That is also a repetitive motion from one peak to the next peak. This is your time period. Or you can even go from here to here, that is also one time period. Or you can go from here to here, that is also one time period. It just repeats, it just repeats, it just repeats, right? That is one time period, right? Yes, very good, you have seen. Your heart beating is also periodic motion. It is also to and fro motion. Your heart will, suck in the blood, it will pump the blood out. It is oscillating back and forth continuously. Your lungs has a different period. The breathing in and breathing out action is roughly around 18 times per minute usually. How many of you know this? How many of you know this? And what is the frequency of the heart beating for an average adult? Let's see how many of you are the true bio students. For lungs, pumping in and pumping out respiration cycles are usually around, I think, 18 if I'm not wrong. Correct me if I'm wrong, my dear students. Yes? Very good, very good. You guys know biology. Very nice. Perfecto. So we have discussed what is frequency, we have discussed what is time period. I will not just go again through that. So an average human heart is found to beat close to 72 to 75 times. Now in NCERT example, they have used 75, that too in physics. So I think the person who made the physics NCERT, maybe he did not call up the biology teacher. So according to the person in the NCERT who made the physics NCERT, right, he has written or she has written 75 times a minute. Don't come and scold me or don't hold my neck, sir, what is this, sir, this is not 75, this is supposed to be 72. It's okay, we'll just assume it is to be true. In a minute, calculate the frequency and the period. Calculate the frequency and the period. Yep. Yes, you can use, Sunita, both the links. The weekly test link is at 9 o'clock. The victory mock test is at 2 o'clock. Victory mock test will have its own parameters and schedule. Your weekly test is only dependent on your current syllabus which is taught in your YouTube sessions. Okay, I hope I have made it very, very clear. Yes, my dear students, it is beating 75 times in 1 minute. 75 times per minute. That is the frequency. 1 minute is how many seconds? 60 seconds. Usually you express it in seconds, right? 75 divided by 15 is nothing but 5. 60 divided by 15 is 4. So 5 by 4 means 1.25 hertz. That is the frequency. That is the frequency. Everybody agrees with this? Now we have to also find the time period. Time period is 1 by frequency. So it is 1 by 5 by 4, which I can write it as 4 by 5 because frequency was 5 by 4. Time period is 4 by 5. 4 by 5 is 0.8 seconds. So that is the time interval between one beat to the next. One beating to the next beating. Okay. I hope this is very, very clear. Okay. This is the same answer which we were expecting. Now that you know the basic parameters, let's talk about what is the equation of a simple harmonic motion. What is the equation of a oscillatory motion? We will also talk about, what are the different parameters involved in an equation of SHM. All these things, characteristics of a simple harmonic motion, that's what we are going to talk about. But then you might be also wondering, sir, why this word SHM came? Why this word SHM came? Let me tell you that. See, my dear students, if you have something which goes like this, okay, something which goes like this, Tell me, is this periodic? Is this periodic? Yes or no? Is this periodic? Yes or no, my dear warriors? Isn't this periodic? Definitely it is periodic. And let's say it tells me where is your position on the x-axis or on the y-axis. So my x position is increasing, going down, going up, and again decreasing, then again increasing, again increasing, decreasing, increasing, decreasing. So you can see that increasing, decreasing, increasing, decreasing, increasing, decreasing, increasing, decreasing, increasing, decreasing of different levels. It is continuously going back and forth. So some kind of oscillation is also there. Some kind of oscillation is also there. This graph or this motion is then called as, simply put, harmonic motion. What is it called? Harmonic motion. The graph will be called as harmonic graph. What will be the graph called as? Harmonic graph. It is periodic, it is oscillating. Very good. So that is harmonic. But look at this. Up, down, up, down, up, down, up, down, up, down. This is also periodic. This is also periodic. This is also oscillating. I'm going left, right. You can say up, down, up, down, up, down, up, down, up, down. So this graph is oscillating, number one. Number two, it is repeating at fixed intervals of time. But then, isn't this graph much simpler than this graph? A simple up and down, simple up and down. Not like while going up it goes down, then goes up. Well, after going down, it does not come up completely. It goes up, comes down, then goes up. This graph is then called as a simple harmonic graph. The motion is called as simple harmonic motion. Simple harmonic motion, which is abbreviated as SHM. And in our syllabus, we have only this. We do not have this. This is called a simple harmonic motion, SHM, which is a simple up and down motion. That's all that we have in our NEET syllabus. We don't have harmonic motion. So you should be very happy about it. So look at this. A bob which is attached to a thread of a pendulum, it's going back and forth. It's going back and forth, right? So this is an oscillating motion and periodic in nature. Look at this. This is a block connected to a spring. You press the spring via the block a little bit and leave it. You will see the spring will push it away. But as soon as it goes away, the spring will get elongated. It will again pull it back. As soon as it comes back, the spring gets compressed. Again, it will throw it away. So it will go back and forth. It will go back and forth. It's like an elastic body which has been compressed and left. It will go back and forth like this. It will go back and forth like this, isn't it? Everybody with me? Awesome. So in any of these kind of motions which is oscillating and periodic, oscillating and periodic, or in general any kind of SHM, you are often interested in the displacement or the position of the particle. Where is it now? I will tell you, hey listen, the time is t. Tell me where it is. You will be like, yeah, it is here. At this time, where it is? Okay, it is here. At this time, where it is? It is here. At this time, where it is? It is here. So you are often interested in the position as the function of time. I will tell you the time, you will tell me the position, or you tell me the position, I can tell you the time. Whatever it is. You can give the time, find where it is. You can tell me where it is, I can tell you when will it be there. So X is basically the where. T is basically the when part. When part. Is that clear? Where is it versus when is it? This is what is called as the equation of the motion. This is basically called as your equation of your motion. Equation of your motion. I hope this is very, very clear. Awesome. Awesome. This function, whatever I have put over here, this function has to be something called as a periodic function. This has to be something called as a periodic function. It will repeat itself. Periodic means repeating function. Now there are only very few equations in mathematics and physics which are repeating in themselves. And the best way to see which one is repeating and which one is not is if you know the graphs of it. And for that, I have a simple graphing software. And let's say, my dear students, I write an equation y is equal to, let's say 4x minus 5. Tell me, do you see this red line? Is this graph a repeating graph? Definitely not. Okay. So this is not a periodic function. This is not something which repeats itself. Alright. So here is what we'll do. We'll change the thing. Let's say we put y is equal to x square minus 2x plus 9. Tell me, where is this gone? Plus 9, I think it went up. Yeah. Is this graph repeating itself? Is this graph repeating itself? Definitely not. This is also not repeating itself. Okay. Let's try something else then. Let's try something else. Maybe let's try x raised to 4 minus 2x square plus 0.2, something like that. Okay. Tell me, is this graph repeating itself? No. I don't see that graph is repeating, but it looks like, you know, some nice curve has been formed, looks very funky. But yeah, this is not repeating itself at regular intervals. Okay, so this is like a big catch. How will a repeating function then look like? Let's try one more thing. Let's try sine of x and see how does it look like. Oh my God, brilliant. Look at it, goes up and down, up and down, up and down. Isn't this a periodic motion, my dear warriors? Very good. What if I put sine of, let's say 4x? Perfect. Even this is repeating. Wow. If I put 2 sine 4x, well, even this is repeating. Okay, I don't like sine. Let's try it out with cos then. Let's try it out with cos. Cos of, let's say 0.3x. Some random thing I've written, but it is repeating itself. I can see that. It is repeating itself, definitely. I can put plus, let's say 2 outside. Yes, even this is repeating. So, sine, cosine graphs are repeating. What about this? Y is equal to maybe 2, let's say, what is it? Sine of x and plus 3, then sine, let's say we put 2x, okay, plus 0.4, and then I'll put sine, and then I'll put 3x, very nice, and see how does it look like. Is this also periodic in nature? Wow, it is. Isn't it? Isn't it? Isn't this also periodic in nature? Very good. Somebody is saying, sir, let's do tan also, sir. Let's get tanned. Why not? Let's try out tan also. Where is tan? Tan of x. Wow. Look at it. It is repeating, but there is a problem. You cannot use this for defining motion because when x becomes close to 90 degrees, when you find the tan of 90 degrees, close to 90, it becomes infinity. That means, look at this, I'll tell you what is happening. I don't know whether I can zoom it over here. I'm not able to. Okay, so when x increases, what happens is this value goes till infinity. So you are going very, very, very far on that side, on the positive side of the x-axis. And as soon as the theta crosses 90 and becomes 90.1, then it becomes minus infinity and comes back over here. Can this happen in real life? That you are going towards the right side, right side, right side, right side, right side in one dimension, and then suddenly you come from here. No, that doesn't make sense, right? So this graph cannot happen in reality. So that's why tan graphs are not chosen for periodic functions. Tan graphs, although they are periodic, but for physics, in physics problems, you never see tan, because how can you find tan of 90? If the value becomes theta becomes 89.99 degrees, value of the tan will become close to infinity. That means you are very, very far away. Tata bye bye only that side. And once 90 degrees is crossed, it will become minus infinity. So from there, you have performed a magic and come from this side. Mind blown. That can't happen, my dear students. Got it? Very good. So now that we have understood it till this point over here, let's also see the different characteristics of a oscillating simple harmonic motion, back and forth motion. So there are always two extreme points. Observe me how I am moving. I'm moving like this. I stop, turn around, and then I go like this. I decelerate, I stop, I turn around, and I go like this. I accelerate, decelerate, stop, and I turn around. Do you see? At two places I turn my direction of motion. I change my direction of the motion. Those are called as the extreme positions. What are they called as? Extreme positions. So at extreme positions, can I tell that the velocity changes the direction? Velocity changes the direction. Not just that, because velocity is changing the direction, that also means it is changing the sign. It is changing the sign. From positive velocity, I am becoming negative velocity. From negative velocity, I am becoming positive velocity. So if minus has to go to plus or plus has to go to minus, it has to cross which number? Which special number? Yes, 0. Definitely it has to cross 0. So that means at this point the velocity is 0, and at this point also the velocity is 0. Is this part clear? Is this part clear? So in any oscillation, what happens? You will stop at the extreme before turning, and you will accelerate, decelerate, and stop before turning. So this is basically your extreme position where velocity changes direction, sign, and that means at that moment your instantaneous velocity at that location at that instant is a big fat 0. Very good. Next important thing, between this point and this point, you accelerate and then decelerate. Again I accelerate and then decelerate. Observe me closely. I stopped, I will increase my speed, I'll accelerate, and then I will decide to brake, and I will stop, and then I will turn, right? Again I will accelerate, and then I will reach a speed maximum, and then I will be like, okay, let me stop. Again I will turn, I'll accelerate, and then I will brake and stop. So there is acceleration, deceleration, acceleration, deceleration, acceleration, deceleration. Half the part is acceleration, half the part is deceleration. Again half acceleration, again half deceleration. Is that right or no? Everybody with me? Very good. So you divide it into two parts. Any one part's distance is called as the amplitude. Any one part's distance is called what? The amplitude. And the exact midpoint is called as the equilibrium position. Sometimes it is also called as the mean position. What is it called as? This position is also called as the mean. Mean means average. This point and this point, average will be here. Average of these two will be exactly here. That's why also called as the mean or the equilibrium position. Everybody with me? Very good. Now tell me, my dear students. What is the distance from one extreme to the next extreme? What is the distance from one extreme to the next extreme? If this is amplitude, if this is what I called as the amplitude, this is also the amplitude. From one extreme to the next extreme, obviously the distance will be 2a. Obviously distance will be 2 times the amplitude. Is that right? Everyone with me? Great. Keep all these pointers in mind. Since I accelerate and then decelerate, where do you think the speed will be maximum? Where do you think the speed will be maximum? You are accelerating, reach maximum speed, then start decelerating till you stop. Accelerate, reach maximum speed, decelerate, stop. So that means, can I say my speed is maximum over here? Can I say my speed is maximum over here? My maximum speed over here, and also while going backwards like this. Is that making sense to all of you? Yes, the mean position is where your speed is maximum. Let's see if you can answer a simple question based out of this. Find average speed and velocity for an oscillating or an oscillation with time period t and amplitude a. Let's see if you guys can solve this particular question. This example. What is the average speed and average velocity for an oscillating particle with some time period t and amplitude a? Let's draw it first, it will be easier. So I start from the mean, I go here, I come back and I come back over here. So like this I go, I come back like this. Remember, this is our mean position. I continue my journey and reach extreme and come back over here, and then it repeats. So I'm traveling A, again A, again A, again A. So if you notice, when I want to find the average speed, right, which is the total distance, it will be A plus A plus A plus A upon the total time, which is t. So it will be 4A by t. Agree or disagree? A. Lot of people think A and A. No, it is A. Understand that. So it is 4A by t. Very good. If you wrote 4A by t, I'm proud of you. The next answer for average velocity, let's see how many students can give this. Average velocity, which is the total displacement upon the total time. Let's see how many of you can give the answer. What is the answer, my dear students? Come on. What is the total displacement? I started, went there, came here and came back. Initial and final positions are the same after one oscillation. I have completed one round. Obviously, it is 0. So hence, the answer is a big fat 0. Average speed is some value. Average velocity is always going to be 0 for a simple harmonic motion. Big fat 0, Krishna. Very good, Sanvi. Very good, Sarath. Abhi, yes, Pranesh. Awesome, Dipanvita. Very good. Excellent. Now that you have understood it till here, let's study some more parameters like displacement. We have studied this. Amplitude also we have studied. Frequency also we have studied. Time period also we have studied. Okay. Now let's study angular frequency, phase constant, velocity. We have seen some part of it, but we'll be seeing the equations also. Okay. So some part of it we have seen. Where is the speed minimum? Where is the speed maximum? How does the direction change? Some parts we have seen. We'll be also seeing the equations. So let's see these new terms called as frequency, phase and phase constant. All right. Everybody ready for this? Let's start. Observe. Let me just create a duplicate over here. Okay. Now we define a term called as angular frequency, whose symbol is omega, whose symbol is basically omega, and that omega, not to be confused with angular speed, that omega is 2 pi divided by the time period, and the unit of that, because 2 pi is in radians, so radians, time is in seconds, so radians per second. But we also know 1 by time period is frequency, so you can also write it as 2 pi f. Both are okay, both the formulas are one and the same thing. What does this angular frequency exactly denote? It so happens that we always associate one oscillation, one complete oscillation. I go back and come back, I go there and come back. One oscillation is generally associated with one complete round. And in trigonometry, remember we have studied this, you start with 0, you go to pi by 2, you go to pi, you go to 3 pi by 2 and you come back. So you complete one round in trigonometry. That angle covered is how many degrees or radians? 360 degrees. In radians it is 2 pi radians. So same way, just like in trigonometry, one round is 2 pi radians. In oscillations, that one oscillation is attributed or corresponds or is related to one oscillation is not, I'm not saying it's equal to, it's corresponding to 2 pi radians. Is corresponding to 2 pi radians. Let's understand this with some example. Let's understand this with some example. Say, if I tell you the omega angular frequency of an oscillation is, let's say, 6 pi radians per second, then can you find the frequency? Yep, omega is 2 pi f. So omega is basically 2 pi f is equal to 6 pi. Pi gone. So how much will be f? F will be 3 hertz. F will be 3 hertz. Are you seeing that? Now let's make sense out of it. 6 pi radians per second. Frequency is 3 hertz. 3 hertz means 3 times it is going back and forth in 1 second. 1, 2, 3. 1 round 2 pi. 2 rounds 4 pi. 3 rounds 6 pi. Yes, 6 pi rounds in 1 second. That's why 6 pi radians per second. That's what it exactly represents. One oscillation, 2 pi radians. When I say 3 hertz or 3 oscillations, so 2 pi, 2 pi, 2 pi. So 3 into 2 pi, which is 6 pi radians per second. That's what it means. Is that clear, everybody? Awesome. Similarly, I can give you one more example. If I tell you the time period of an oscillation is 0.2 seconds, find the omega. So omega will be 2 pi divided by 0.2. So omega will be 2 cancels, this is 0.1, so it will become 10 pi radians per second. 10 pi radians it is covering in 1 second. One revolution, one oscillation is 2 pi. So 2 pi, 2 pi, 2 pi, 2 pi. Like that, to become 10 pi, it needs to go 5 times. So frequency will be 5 hertz, and it is 5 hertz because you can calculate f as 1 by t, which is 1 by 0.2. So the frequency will come out as 5 hertz. 5 times it's going back and forth, back and forth. That is the true meaning of omega. How many of you got a feel of omega now? How many of you got a feel of what omega is right now? Let me know in the chat box. If you got a feel, put up a heart in the chat box for me. Put up a heart in the chat box for me if you got a feel of what omega is. Angular frequency, right? And one oscillation is 2 pi radians. Just like in trigonometry, one revolution is 2 pi. So here one oscillation is 2 pi, corresponds to. So if I say 10 pi, that means 5 rounds I have done. Got it? Got a feel? Very good. Excellent. Yes, can we say 1 hertz is 2 pi radians? Yes. Who is that? Malakordi, definitely. 1 hertz means you have completed. You can see that f is 1. If you put f as 1, you will get it as omega is 2 pi radians per second. 1 hertz frequency is 2 pi radians per second. Perfectly. Very good. Very good. Let's go to the next parameter. So we have done this also. Angular frequency also done. Now what is this phase and this phase constant? Okay, let's talk about it. One day I asked Pandu, how are you? Pandu said, I am very, very sad. Why? Champa left him. Next day I asked, what happened, Pandu? How are you today? Pandu said, I am very, very happy because I found a new Champa today. Next day I asked, what happened, Pandu? How are you? Pandu said, I am okay. This new Champa is not that great as the old Champa. Next day I asked, what happened, Pandu? How are you? Pandu said, I am very sad. This Champa also left me. So these are different situations of Pandu. You also call them different phases of Pandu. Different phases of Pandu's life. Just like you have phases of moon. The moon's phases are there. You see the big crescent, then the full moon, then maybe something like this. So these are different phases of moon. These are different situations. So even in a oscillation, there are different phases. Right now, the oscillation is here. Then the oscillation is here. Then the pendulum is here. Then the pendulum is here. Then the pendulum comes here. Then the pendulum goes here. So these are different phases of the pendulum. Understood? Everybody with me? Very good. Yes. So, phase of a SHM means, hey SHM, what is your current situation? How are you? You are just asking, how are you? Hello, mister, how do you do? That's all we are asking. Okay, that is the meaning of phase. So, phase is how are you? It's basically telling you the situation it is in. That's all. Situation it is in. Now, if phase tells you, how are you? Can you tell me what does initial phase mean? Initial phase mean? What do you think is the initial phase? Initial phase means when you began the time, when you just started, that means t is equal to 0, that time how were you? Initial phase means your initial condition, initial situation, how was it? How was it? That initial phase is also called as the phase constant. What is it called? Phase constant. What is it called, my dear students? Phase constant. Initial phase. How are you initially? Phase constant. How are you now? That is just phase. I am in a very happy phase of my life. That is my phase. Your phase constant. How was I at t is equal to 0? You're like, sir, at t is equal to 0, I was born, sir. I was crying, sir. I didn't know about NEET, sir. I was just, born. I was, just drinking, eating, and just, going to the toilet. That was my initial t is equal to 0 phase constant, sir. Yes, correct. Very good. That's the best phase of your life because you are, in the care of your parents. You don't have to worry about anything. No exams, no tension. So now this is the phase where you have to worry about your NEET exam. Correcto. Perfecto. Yes. Can you increase 200 marks from now? Myth log. Obviously, if you study under me, you will increase even 300 marks. That depends now. If you're at 600, then you can only increase till 120. Yeah, but if you are at 300, definitely you can come to 500. If you are at 200, you can definitely come at 600 also. But it all depends on, did you find the right teacher? Did you find the right guidance? Did you follow the teacher's advice? Are you sincere to yourself and the teachers and the entire books that you are studying? Are you utilizing those books and solving adequately? Are you putting in that hard work? All these things matter. Okay. Now, what is the symbol for phase constant? The symbol for phase constant is just phi. What is the symbol for phase constant, my dear students? Phi. So, when Pandu began his relationship, his initial phase would be represented by phi. If I ask Pandu, what is your phi? He'll be like, with Champa. He'll be like, when I started meeting this Champa, that time it was very nice, sir. For love at first sight. That is Pandu's phi. Understood? I hope this is very, very clear. Yeah. So frequency as one more unit, right? Cycle per something, that is RPM. We have seen that, or we will see that in circular motion, rounds per minute, rounds per second. So it's the same thing. RPS is one and the same thing, right? So if I go back and tell you about, where is it? Yeah, hertz per second. You can also have another unit. You can call it as rounds per second. RPS. So one round in 1 second is basically 1 hertz. But if you talk about RPM, it's how many rounds you are doing per minute. How many rounds you are doing in 1 minute or 60 seconds. So you convert minutes into seconds, you will get it rounds per second or in hertz. Is that okay? Great. So now moving ahead. So we have talked about what is the meaning of phase and what is the meaning of phase constant. The symbol for phase constant is phi. The symbol for phase constant is phi. You might be wondering, what is the symbol for just the phase? What is the symbol for just phase? So phase constant, my dear students, is phi. Velocity we have already seen is a v. Time period we know is t. Frequency we know is f. Angular frequency we know is omega. Amplitude we know is a. Displacement is your x value, how much have you moved. What is the symbol for just the phase? The symbol for phase is omega into t plus phi. Whatever you get, phi plus omega t. Kind of makes sense. Kind of makes sense. Think about it. Omega is how many radians you move in 1 second. Just think about it. Oops, what just happened? Just think about it. If I tell you, you are going you are going 10 pi radians in 1 second. You have waited, or you have been peaceful for 2 seconds, let's say. So you waited for 2 seconds. You would have covered how many radians? Second cancelled, 10 pi into 2. You would have moved 10 pi radians. But initially, you might already be at maybe pi radians. You might initially already be at pi radians. So, what is the total radians that you have covered? 20 pi plus pi is 21 pi radians. 21 pi radians. This is your phase. This is your phase, my dear warriors. This is your phase, my dear warriors. And this one that you see over here, that is your phase constant. That is your phase constant. This one that you see over here is omega. This one you see over here is time. That is the reason why you will say that your phase is nothing but angular frequency into time, radians per second into second, plus your initial phase, which is phi. Is that clear, everyone? Everybody with me? Understood? Clearo? Perfecto? Can we move ahead? Yes, a very, very important formula. A very, very important formula. The phase of a SHM is omega t plus phi. When you put time as 0, you will get initial phase, which is over here. Okay? So this phi is also called as your initial phase, or just the phase constant, Keep this in mind. Great. So we have studied all these terminologies now. The characteristics of simple harmonic motion. So now it's time to actually see the equation of a SHM. Finally, we will see the equation of a simple harmonic motion and the graph and everything. Graphically, we know how a SHM should look like. So let's just probably draw it over here like this. Okay, so this is your X, this is your time, this is origin. Maybe the graph goes like this, like this, like this, like this, like this, like this. I've just shown few oscillations. That's okay, perfectly fine. This is time, this is position. So from one trough to another trough, or from one crest to the next crest, that gap is not wavelength. Please don't take me wrong. This is actually the time period. What is this? This is basically the time period. Okay, from one point to the next identical point, one point to the next immediate identical point is basically your time period of oscillation, right? Similarly, my dear warriors, what is this going to be? What is this going to be? This is going to be the amplitude. This is just going to be the amplitude, right? From here to here, or from here to here. This represents one of the extremes. This represents another extreme. Extreme and extreme. Two extremes. Okay? This is the mean. This line represents what? Mean. I will just rewrite it over here for your benefit. That's all. That's all. Okay? So just write it over here. This line over here. Okay? These are basically your extreme positions over here. This is also extreme positions over here. And this line in the exact middle is your mean. It's the average of these two. It's exactly middle of these two. Make sense? Now, what is this graph actually telling us? This graph is actually telling us, hey, listen, you have a particle, and it is moving back and forth. Maybe now the particle is over here, We'll do one thing. This is your x-axis. The particle could right now be over here. Let's say this is your x value. This is your x value. That means the x position, the current location of the particle. Maybe, you know, you can also call this one as your mean position, where it is basically originating. So it is also the origin. Right? Right now it is here. It goes till here, comes back. It is oscillating between some 2 points over here. It's oscillating between some 2 extreme points over here. This is one of the extreme. This is another of the extreme. You tell me the time where it is, I can find out. Oh, at this time it is here. At this time it is here. At this time it is here. At this time, this is the value of x. At this time, this is the value of x. At this time, this is the value of x. So that's how you get to know the value of x, my dear students. So you tell me the time, I will tell you where it is. You tell me the time, I will tell you where it is. So you tell me the time, I will tell you where it is. Is that clear? What this is graphically, what this is actually? The particle is not going like this, No. The particle is going like this. This is the graphical representation of it. How many of you are learning many things in SHM now which you might not have learned in school or your regular coaching? I'm pretty sure many of you are doing it like right now, right? So that's why this lecture is super duper important, and I hope you are showing your immense love and support by supporting the channel by subscribing and supporting this video by liking this video. Okay, if you haven't done that right now, please do it. It means a lot when you subscribe, hit the bell icon, and also smash the like button down there. Great. Awesome. Now, what does the final equation look like? The equation looks like this. X is equal to A sine, and here inside you have basically the phase. Here you basically have the phase. So it is nothing but A sine omega t plus phi. The situation will change, the sign will change, the value of x will change. Situation changes, x changes. Situation changes, x changes. That's all. That is the equation of SHM, as simple as that. X is equal to A sine omega t plus phi. Everybody with me? Done, dusted. What is the equation of SHM? X is equal to A sine omega t plus phi. Or in some books they might also use cos. That's also okay. X will be equal to A cos omega t plus phi. Don't use tan. Okay, I'll put it over here. Don't use tan, cot, cosec, all these things. Not allowed. Please don't use that. Okay, don't use these other trigonometric functions. Only sine and cos. No tan, no cosec, sec, or no cot also. Keep this in mind. Okay. Now that you have understood it till here, maybe we have seen all these things. Let's have a look at some questions. So all these things we have done, right? We have seen x as a function of time. Yes. You tell me the time, I'll tell you where it is. Amplitude, yes. Omega is angular frequency. Omega t plus phi is phase. Phase constant is the initial one. So that is phi. We have seen all these quantities and their standard symbols. Let's see exercise, in text question 2. Okay, which of the following functions of time represent periodic, non-periodic motion? Give the period for each motion. Omega is some positive constant. All right, so let's have a look. Let's see if we can create a duplicate slide. Already, I think duplicate slide is created for each one of them. Okay, great. Chalo, let's do this. Sine and cos are periodic. Yes, not just periodic, Malakodi, it is also continuous. That means there is no gap in between. Tan, cot, etc. they are periodic, but they are not continuous. That's the problem. I mean, at 90 degrees, 270 degrees, there is a discontinuity in the graph, which makes them unsuitable for representing real world scenarios. That is the problem. Okay. So my dear warriors, let's have a look at these questions. Sine omega t plus cos omega t. If you look at this one, sine omega t plus cos omega t, I can do one thing. I can write it as sine omega t into let's say sine 45 degrees plus cos omega t into cos 45 degrees. Reason is sine 45, cos 45 both are 1 by root 2. So to preserve the equality, I'll just multiply by root 2. See if this is okay. Because I know for a fact sine 45 is 1 by root 2 and even cos 45 is 1 by root 2. Root 2 will cancel. Root 2 will cancel. This formula is very familiar. Sin A sin B plus cos A cos B. Sin A sin B plus cos A cos B is nothing but sine of A plus B. So it is sine of omega t plus 45 degrees. And that root 2 will come over here. Usually you put not in degrees but in radians. So root 2 sine of omega t plus pi by 4 usually you put in radians, not in degrees, right? So now isn't this like your equation of SHM? X is A sine or cos omega t, X is A sine or cos omega t plus phi. So it's exactly like that, where this is your amplitude, this is your phase constant, this is your actual omega. So question is it periodic? Yes. What is the time period for this? Basically time period will be 2 pi by omega. That is the answer, and it is periodic in nature. Is that understood, my dear warriors? Isn't it simple, straightforward? Pakka? Great. So sin omega t plus cos omega t done. Let's go to the next one. It says sin omega t plus cos 2 omega t plus sin 4 omega t. What do you think? There are three functions together. Three functions together, just added together, that's all. If you look at the second one here, this sin omega t has a time period of, basically 2 pi by omega. Cos 2 omega t has a time period of 2 pi by 2 omega, and this sin 4 omega t has a time period of 2 pi by 4 omega. I will call this T3, I will call this T2, I will call this T1. These are individual time periods. Each one of them are periodic and have different periods. So they will repeat again after some time, 100%. So you can see over here, if this is T3, this T1, if I multiply 4 times T3, I will get T1. 4 into T3, I will get T1. And same way, I will also get T1 by multiplying 2 with T2. 2 times of T2. What it means is that, observe, if I take T3, if T3 is some seconds, this is T3, again T3, again T3, again T3, 4 times, I will get 1 T1. I will basically get 1 time period of 1. And 2 T2 is T1, means you take T2 2 times. You will get 1 T1. So do you see, whole thing together repeats after T1, not T3. If you see over here, if I started right over here, after T3 it is not repeating. After T2 also it is not repeating. After T1, it's exactly the same thing. This block gets repeated. So what is the actual time period? My dear warriors? It will be T1. So T1 is nothing but 2 pi by omega. So that is also periodic in nature. If you read the example in NCERT, you will be very super duper confused, and many teachers you might have seen do not explain this problem really well. Understood, guys? What is the meaning of this? Right? T3 was the smallest of them all. T2 was okay. T1 was the biggest. So after 1 T1, you will see all of them would have completed some 2 or 3 periods or something like that. And after this, it just repeats the block. The block just gets repeated. Understood, my dear warriors? Pakka? Awesome. Super duper. Now, if you talk about third and the fourth, either this or this is exponential function, this is logarithmic function, exponential, logarithmic, inverse trigonometric, all these functions often are non-periodic in nature. So I'll just say that they are non-periodic. Their graphs don't repeat themselves. Examples of them are logarithmic, exponential, quadratic equation, linear equation, reciprocal of a function, and so much more. So many other functions, either which is not sine or cos, they are not going to be periodic in nature. Keep this in mind. As simple as that. Okay, they do not repeat themselves. Next one. Which of the following function, this is the next in-text question, is SHM periodic but not SHM? Give the period for each case. Are they simple harmonic? Are they periodic but not simple harmonic? What do you think for each one of them? I think these ones are straightforward. Let me just create a duplicate of this. If you talk about the first one, if you talk about the first one over here, I can just write it as sine omega t. Again, write 1 by root 2 minus cos omega t into 1 by root 2 and just multiplied by root 2, preserving the equality. Just take that root 2 on this side. This will become sine omega t and sine 45. I can just write it as sine of pi by 4 minus cos omega t, which is also the same as cos 45, which is cos pi by 4 radian. This will become root 2 sine A sine B minus cos A cos B is sine A minus B. So sine omega t minus pi by 4. So now you can definitely see this is your amplitude, this is your omega, this is your phase constant. So the time period will be 2 pi by omega, and it is a SHM. Definitely it is also periodic in nature. It is definitely like a SHM equation. Is that right? Why not T3, Madhumita? Think about it like this. One person, he is doing something after 1 second. Other person is doing it after 2 seconds. Other person is doing it after 4 seconds. This is 1, 1, 1, 1. This is 2, 2. This is 4. So when are everything repeating themselves? Is it after T3? No. After T3, T2 has only done half of whatever it was doing. T1 has done only 1/4. So even after T2, T1 has not completed its complete event or oscillation. So that's the reason why T1, the largest one, it's like LCM, least common multiple. So that is why T1 is the time period. You have to wait at least T1 seconds or 4 seconds example, so that all the things fall back into the exact same way they were at this point of time. Whatever happened here should happen after this. Only then it will be the time period, right? Does that make sense? Okay. Now, next one. What about sine square? I think that's a standard formula. Cos 2 theta is 1 minus 2 sine square theta. So, therefore, 2 sine square theta is 1 minus cos 2 theta. Therefore, sine square theta is 1 minus cos 2 theta divided by 2. So use the same logic over here. You will be getting half minus half cos 2 omega t. This is just some constant, that's okay. This is basically some constant, that's perfectly fine. This is like your amplitude. This over here is your omega, and there is no phi over here. Phi is basically 0. So therefore, I can say that the time period is 2 pi by omega. Omega over here is 2 omega. So the time period is pi by omega. So Is it periodic? Yes. Is it SHM? Yes. Is it periodic? Yes. Is it SHM? That is also yes. Yes. All should repeat. I mean, Madhumita, think of it. Everything should come back into the same place as it was before. Think of it this way. There is a ground. Okay, think of for that problem. Na? Best example is think of a ground. One person is very fast and he completes the round in 1 second. 1 second. Okay. Another person is there. He completes the round, but he takes 2 seconds. Another person is there. He completes the round slowly in 4 seconds. So what do you think will be the period if they start together so that everything repeats as it is? Is it 1, 2 or 4? Answer it in the chat box. Is it 1, 2 or 4? Answer it in the chat box. After 1 second, the orange fellow has completed the round, but this guy has only completed half the round. This guy has only reached here. Correct? So if you want everything to be at the same place, same line, same starting position, what will you do? You will wait for the 4 seconds guy to come here. Meanwhile, 2 seconds guy would have completed 2 rounds. 1 second guy would have completed 4 rounds. So then everything will be at the same place. Now it will repeat. After this, again after every 4 seconds, it will repeat. So basically in this case, the time period will be 4. The time period will be 4. Understood now? I hope this is very, very clear. These things, are simple things, but you need to visualize, and I think many people don't know how to visualize this, and that's the reason why you need to take help of teachers like me. Many people, I have seen many teachers don't explain these things properly. So I'm very happy that you kids are asking these doubts. I'm so happy, trust me. It makes me very delighted that you are asking me these questions, because these are very, very important things for your understanding. Let's see if you guys can solve this. A particle, it undergoes a simple harmonic motion with a time period of 2 seconds. In how much time will it travel from mean to half the amplitude? Mean to half the amplitude. Come on, think about it. What do you think should be the correct answer? What do you think should be the correct answer? Let's visualize it for some time so that we get a feel, and maybe I might not need the diagram. It's just for the feeling, for satisfaction's sake we'll draw it, and then we can use the equations. Well, we all know that SHM will go back and forth like this. There will be a mean position which is 0, and there will be extreme also. What time will it travel from mean to the displacement equal to half of its amplitude? Half of its amplitude, that means exactly at the midpoint, the value of x must be a by 2, because this thing is the amplitude. This thing is the amplitude. Is that right? This is where it is. So essentially it started from here, it went here. How much time did it take? That is what it is telling. If it starts from here, and reaches here, to find the time, let's say we use this equation, x is equal to a sine omega t plus phi. Actually, don't even use phi over here, just use a sine omega t, because I know since at t is equal to 0, if you put time as 0, sine 0 will be 0, that means x will be 0, that means you are at the mean position. This is initially. Don't even need phi. Phi is not required. You are at the mean when time was 0. Is that right? Everyone with me? Till this point? Excellent. So now, if you have to reach here, then x value is a by 2. So this is a sine omega and t. A cancels, sine, I will have omega, t is equal to half. A cancels, it will become half. That means whatever is there inside, that must be 30 degrees or pi by 6. That must be 30 degrees, but everything is in radians. So pi by 6 radians. Next point, omega value is nothing but 2 pi by the time period. What is the time period? The time period is 2 seconds. So I will put 2. Did you understand? I have replaced omega with 2 pi by t, which is the time period, into t is equal to pi by 6. Pi by 2 by. So what will t be? 1 by 6 seconds. Oh, it reached at a by 2. It reached at a by 2 at 1/6 of a second. Is it there? B for biology. Is it there? Yes, it is the correct answer. Got it now? No, it is not option A, it is option B. Clearo? Clearo? Thank you so much, Sarath. Means a lot. Yes, these kind of questions are very, very common. Very, very common. Moving on. Now, before we go to velocity, let me tell you one important thing. If you have a SHM, and at t is equal to 0, it is starting to go here, I would suggest use the equation x is equal to a sine omega t. X is equal to a sine omega t, because if you look at the graph of this, sine graph always starts with 0, then goes up and then goes down. Sine graph always starts with 0, then becomes positive, negative, and so on and so forth. That's why use a sine omega t if it is starting from here. But in certain situations, it might so happen that you are starting only from here, from the extreme. You come to mean, go to extreme and go here. So because you are already at the extreme, that means the maximum value. So you will start from the maximum value and go down and up like this. So which kind of graph will that be? It will be a cosine graph. So use a cos omega t preferably. If you are starting from here, use a cos. If you are starting from here, use a sine. Do you see the difference? That's all. Yes, awesomeness. B for Baswaraj sir too. Exactly. Perfect, perfect. So that is the reason why I started off by using at time 0. Since it was there, I used a sine omega t. That is a small trick for saving lot of time in the examination. Okay. Now let's talk about velocity. Let's talk about acceleration and also the graphs of them. So starting off with velocity. So here we know that x is nothing but a sine omega t, right, plus phi. If I want to find the velocity, velocity is nothing but the derivative of x with respect to time. When I take the derivative, a is a constant, so take it outside, d by dt of sine omega t plus phi, yes or no? Now when I take the derivative, what will happen? Sine's derivative is cos. Sine's derivative is nothing but cos. So cos omega t plus phi. But using chain rule, you will see that omega will also come outside. Even omega will come outside. So it will become a omega cos omega t. A omega cos omega t. This is the velocity equation, my dear students. What is this? This is nothing but the velocity equation. Keep this in mind. Very, very important. Malakodi, as we solve more problems, you will get the concept understanding very clearly. So see the questions, solve the same questions what I did, and then also solve the easy peasy questions from your textbook, and then go to average, then go to PYQ. Never jump to PYQ. Here when I do the PYQs, I am explaining, that's okay. But when you do it on your own, always increase the level slowly. Now what I will also do is that, okay, what I will also do is that, one second, let me remove this. From here, I can find the value of sine omega t plus phi, which is nothing but x by a, right? So from here, I can also find the value of cos of omega t plus phi, which is nothing but v by a. Now I got an idea in my mind. What if I do sine square omega t plus phi plus cos square omega t plus phi? Let's see what do we get. Sine square plus cos square. Sine square, that means x by a whole square. Cos square, that means v by a whole square. What do I know? Sine square plus cos square. Sine square plus cos square. What is it, my dear students? Isn't it 1? Sine square plus cos square. If you add both of these, what will you get? You will just get 1, right? That's a standard identity. Here, I'm getting x square by a square and v square by, a omega should be there. My bad, I forgot that omega. So sorry guys. V square by a square omega square. So there is omega also over here. My bad, omega is also there. So now what I will see on the next slide, observe, this will be x square by a square plus v square by a square omega square, correct? Till this point everything is clear? Awesome. Now what I will do, I will just cross multiply and see what will happen, take LCM and all of that. Okay, so first of all take a square on the top. So a square is equal to x square plus v square by omega square. Shift x square over here. So it will become a square minus x square is equal to v square by omega square. So what will be v square? Taking omega square on the top, it will be a square minus x square. So what will v be? It will be omega root of a square minus x square. This is also a very important formula. Many times when time is not given or not asked or not required, directly you can relate x with v. Very important formula. If time and velocity relation is asked or given or some way or the other, what just happened to this? Oh, this slide came over here. Then you use this. Okay, so I'll just put it over here. Yes, when time and velocity relation is asked, then you use this. Is that okay? Perfect. Now, what is the maximum or minimum value of cos? For cos, what is the max value and what is the minimum value? The max value is 1. The minimum value, magnitude wise, I'm not talking otherwise, it is 0. Maximum is 1, minimum is 0. So here, if you take the modulus of velocity, the max value, what is the max value and the minimum value? Basically, I'm talking about the speed over here. That's why I've taken modulus. So what is the max and the mean value? Because maximum cos is 1. So the maximum v value will be a omega, and the least value, because cos will be 0, that will be also 0. So that's why the maximum speed is a omega and the least speed is 0. Where is the speed maximum? It is at the extremes. Both the, not extremes, at the mean. When you are going from the mean position, you're going like this. When you're going from the mean, either here or here, that time your speed is maximum, correct? And where is your speed 0? At both the extremes. Keep this in mind. So the maximum speed is a omega, minimum speed is 0. Another important point which everybody should note. Excelente. Perfect. Let's go to acceleration. My dear warriors. Let's just create a duplicate. Okay, over here. Let's just have a look at acceleration. So now we just saw some time back, velocity was a omega into cos omega t plus phi. But we know acceleration is derivative of velocity. A and omega are constant, so bring them out. So it's just the derivative of cosine omega t plus phi. So therefore, acceleration will be a omega as it is into derivative of cos is minus sine omega t plus phi, and this omega by chain rule has to come outside, so into omega again. So this will become, take the minus sign properly, and a omega square sine omega t plus phi. That is what the acceleration is going to be. Acceleration is going to be minus a omega square sine omega t plus phi. Cool? Very good. Now I can do a small trick over here. How about writing this as minus omega square brackets a sine omega t plus phi. Just check this out. Does this remind you of something? I just taken omega square with negative sign outside the bracket. I have clubbed a with sine function. What is this actually? Actually, a sine omega t plus phi is x. Actually, that is nothing but inside that is just x. So can I also write acceleration is minus omega square into x? That's also another beautiful formula which everybody must know. This is a beautiful formula. Acceleration related to x without time. If x is not given, acceleration and time relations are asked, then you use this. So it's something like this one. Here there is no time, then you use this formula. But when time is there, then you will use this formula. Interesting thing to note is that if your x value starts with sine, then it goes to cos. Look at this. If x is a sine omega t, forget phi, then velocity will go to cos, so it will become a omega cos omega t, and then acceleration will become minus a, again back to sine, so minus a omega square sine omega t. As you go down, one extra omega will add up. Extra omega will add up. That's the main difference, my dear students. So if you look at the graphs, to look something like this. So this is x, this is v, this is a versus time, of course. If x graph is a sine graph, then velocity will be a cos graph, something like this. Little bit difficult to draw, but yeah. And acceleration will be again sine, but with negative value. That means sine graph should be inverted because it is negative. So just flip it, so it will just look like this. Okay, so sine, cos, minus sine. That's how it will look like. Amazing. Perfect. Awesome. So my dear warriors, over here, what will be this value? What will be this value? This will be a. That's the maximum displacement. My dear warriors, what will this value be? Maximum speed, which is a omega. This is max speed. This is max speed. This is max displacement. Max displacement. What do you think this value will give you? What do you think this value will give you? Quickly, it will give you a omega square. Exactly. It will give you a omega square, which is max acceleration magnitude. Maximum acceleration's magnitude. Is that right? Maximum acceleration will be a omega square. Can you quickly think and tell me, where will the acceleration be maximum? Where will the acceleration be minimum? It's a very, very straightforward thing, but let's see if you are able to figure that bit out. Let's see if you are able to figure that bit out. Where is the acceleration maximum and where is the acceleration minimum? Look at this, my dear warriors. You can see when x is 0, a is 0. X is 0, a is 0. That means x is 0 at mean, so acceleration is 0 over here. So acceleration is 0 and it is also minimum. It is also minimum over here. Where do you think it is maximum? When acceleration is maximum, x is maximum. What's the max value of x? X value maximum can be a, which is amplitude. It can't go beyond that. So the value of x can be maximum a or minus a. So here a is basically maximum. A is basically maximum. Everybody with me? Understood? Clearo? Perfecto? Awesomeness. Awesomeness. Also another beautiful graph of cosine. If your x starts as a cos omega t, then velocity will be a omega, cos's derivative is negative sign, sorry. So minus a omega sine omega t, that's what velocity will be. And acceleration will be derivative of this. So it will be minus a omega square, sine's derivative will become cos. So cos omega t. So that's how the equations will look like. If you start with a cosine function, if you start with a sine function, then it looks like this. Okay, you can see a cos means maximum value, it will start off with. Then minus sine is up and down, minus sine will be down and up. Minus cos, so whatever cos graph was, exactly opposite. You start from negative maximum, then go to up and then down. Okay, so that's how the graphs will vary, my dear warriors. Yes, in fact, I can summarize this over here in this beautiful way. Observe this. If you take this SHM, where this is your mean, this is your extreme, this is also your extreme, this is amplitude, this is also amplitude, then your velocity while going here is maximum, which is a omega. Also the speed while going like this is maximum, so it is V max, which is again a omega. The speed is minimum here, so V minimum is 0. Here V minimum, again it's 0 at extreme. Acceleration is minimum here, either when you are going this side or that side, doesn't matter. As you are crossing this point, acceleration is 0, and acceleration is maximum here. So here you will have maximum acceleration, which is magnitude wise a omega square. So this is again over here max acceleration, which is a omega square. Is that right? So this is a very, very good graph or a visualization, or I would say chart, which will help you clear all your doubts. Cool. So all these things you'll get in the notes. Okay, so make sure you're a part of the Telegram channel. Link is there in the description box. Be a part of it so that you can get all my handwritten notes. There is no absolute any kind of confusion, because many teachers don't know how to teach this chapter. I've seen it on the internet. Very few teachers actually can teach this complicated mathematical chapter, specifically that too for NEET students. Okay, because you know you don't study maths as a subject, most of you, and this chapter might become a little bit mathematical, trigonometric functions and all of that. So you need to actually sit and visualize these things, and if you're not able to relate it, it's gone. Okay, so let's solve these questions. NCERT exercise 13.5, body oscillates with SHM according to the equation x is 5 cos 2 pi t plus 5 by 4. At 1.5, find the displacement, speed and acceleration. That's all. That's the question. Let's solve this, everyone. Okay, so first of all, at 1.5 seconds, find the displacement. So if we start off with this problem, x I want to find out. Substitute the value of time. So cos 2 pi into 1.5 plus pi by 4. So this will become 5 cos 2 pi into 1.5. That's going to be 3 pi. So 3 pi plus pi by 4. What do you do with this cos of 3 pi plus pi by 4? Cos of 3 pi plus pi by 4. What will you do, my dear warriors? Think about it. 3 pi, you can write it as 2 pi plus something if you want. 3 pi, you can write it as 2 pi plus pi by 4. Because everything repeats in trigonometry after 2 pi, it's as good as writing cos of just pi plus pi by 4. Cos of pi plus pi by 4. Which quadrant are you in? Pi is 180. So you are in the third quadrant. In the third quadrant, all silver T. Only tan is positive, cos is negative. So I will get minus 5 cos pi by 4. 5 by 4 is 45 degrees. So it will be minus 5 by root 2. that is the value of x that I should get, minus 5 by root 2. How many of you understood this, what I just did? Everyone? Okay, so what I did, 3 pi is more than 2 pi, so I wrote it as 2 pi plus pi. 2 pi cycles, it will repeat itself, so forget that 2 pi, it's anyways going to repeat. So I'm just left with pi plus pi by 4. Then after this, I will use cos of pi plus theta is minus cos theta, minus because in the third quadrant cos is negative, and cos of 45 is 1 by root 2. That is the answer for this. Once I get this, I can also find the speed and all those other things, because velocity will be a omega, oh, this is cos. So cos's derivative will be minus sign. So minus, because this is actually a cos omega t plus 5. So if x is this one, velocity will be derivative of this. So minus a omega sine omega t plus 5. That's what it should be. So therefore the velocity will be minus amplitude is 5, omega is 2 pi. This will be sine of, again the same thing I will get. Omega is 2 pi time is 1.5 plus pi by 4. That's what I will get. Then you can write it as minus 10 pi, 5 into 2 pi is 10 pi. Sine of 3 pi plus pi by 4 is sine of pi plus pi by 4, which is again minus sine pi by 4, which makes it positive, minus is plus. So 10 pi sine 45 is 1 by root 2. That's it. So that many meters per second is the answer for this one. Okay, so we got the second answer as well. Everyone with me? Understood or clear? Very good, very good. Awesomeness. Last is acceleration. I can use the equation or just use minus omega square x formula. So minus omega value is 2 pi. So square it into value of x, which is 5 by root 2, which is basically 5 by root 2, and that is also with a negative sign. So minus and minus makes it plus. 2 square is 4, pi square is pi square, into 5 by root 2, 4 5s are 20. So 20 pi square by root 2 meters per second square. That is the acceleration. 20 pi square by root 2. Is that right? Everybody? Very good. Excellent. Yes. What about you all? Copy or, well, what are you saying? No, don't copy the notes right now. You can just scribble the problems. That's all. Notes, you will get it in the Telegram group. And once you are a part of it, you can just download it. Number one. Number two, while rewatching these classes or when you are making your notes, that time you can copy the theory points from my notes over here. Okay, don't copy when you are listening, because I want you to focus on the class, not on just making your fair notes. You can make running or rough notes. Rough notes is what is recommended. Don't make continuous notes or don't make your fair notes. You can just solve the problems with me or just mark it in your NCERT or mark it in your own notes if you have already made one. Okay. Variation of acceleration of a particle executing SHM with displacement x is how much? Come on, think about it. Yes, Sosindra, this is basically a long marathon. It's not like I can do one thing. I can break the lecture into 45 minutes and take it for 4 or 5 days. But I don't do that. We do it as a one shot. Okay. What do you think is the graph of particle executing acceleration with displacement x? Acceleration is minus omega square x. So acceleration is proportional to negative x. If acceleration is proportional to negative x, it must be a straight line with negative slope. Isn't that true? Acceleration should be a straight line with negative slope. There is only one graph like that. Option number 2. It's negative slope and it's a straight line. Everybody got it? Thumbs up. Shall we move ahead? Very good, very good. Keep it up. Moving on to the next one. A point performs SHM, time period t, equation of motion is this. After elapse of what time period fraction, the velocity of the point will be equal to half the maximum velocity. Velocity should be half the max velocity. Okay, let's solve this. What's the max velocity? Any SHM, it is always a omega. Half of max velocity will be a omega by 2. So that should be the velocity of the particle. That should be the velocity of the particle. Great. Since x is a sine omega t plus pi by 6, therefore velocity will be, just taking the derivative dx by dt, should be a, or just a omega, here I will have cos because it is sine, it will be cos omega t plus pi by 6. Everybody understand it? Everybody is understanding this point? I've just taken this equation and I have just differentiated. I get this, which is a standard thing which you would have memorized by now. But v is a omega by 2. What is v, my dear warriors? V is nothing but a omega by 2. Okay, is equal to a omega cos omega t plus pi by 6. Perfect. A omega goes. So cos of omega t plus pi by 6 is equal to half. That means omega t plus pi by 6 is actually pi by 6. Is actually pi by 6. Is that right? Everybody with me? Perfect. Very good. Because, oh sorry, not pi by 6, pi by 3. Alright, pi by 3. Cos of 60 is half. So whose cos is half? That is 60 degree, which is pi by 3. Now just rearrange this. Now just have to rearrange this. So what is omega t equal to? Pi by 3 minus pi by 6. 60 minus 30. 60 minus 30. It is again 30. So the answer over here will be just pi by 6. Omega is itself 2 pi by the time period, and that is t over here. Pi goes off. Pi goes off. So the value of small t will be, t goes on the top, 6 is below, this 2 comes over here, so that will make it t by 12. T by 12. How many of you got the answer as t by 12, which is C for Captain Shreyas? Yes. Perfect. Proud of all of you if you got it. Excellent, my dear students. Okay, so we have just gone purely mathematical. You should know a very good trigonometry. That is why I did basic maths very early. If you have not watched the basic maths trigonometry, please watch it. It's there on this channel. And I've just used the equation of velocity as it is, which you have learned before. I substituted velocity as a omega by 2 and then used simple trigonometry and maths. That's all. Next one. Particle executes SHM with amplitude 3. When it is 2 away from mean, magnitude of V is actually equal to the acceleration, then what's the time period? Interesting. Listen in carefully. The magnitude of its velocity, that means V, or this one, is equal to the magnitude or just of its acceleration. Okay, the magnitude of its velocity is equal to the magnitude of its acceleration. So what is the formula for velocity? I think I know it. Omega root a square minus x square. You might be wondering, why am I not using a omega cos omega t plus phi and those things? Read the question. Do you ever even see time mentioned? Forget time period. Time at this time, at 2 seconds, at 3 seconds. No. When there is no time, why do you want to waste that equation? Why do you want to bring time in the first place? It is not even given. Why bother bringing it? It's not even required. Okay. Then what about acceleration? Don't bring time. Think, is there some equation which you already know? Yes, it is omega square x magnitude wise. Wow. Now omega gets cancelled and I think we'll be with something. So root of a square minus x square will be omega x, square both sides. So a square minus x square will be omega square x square. What we want is time period. Okay, so bring Oh, we just wanted omega, right? Okay, so I don't have to even square this. So just substitute the value. What is the amplitude? Amplitude is 3. Amplitude is 3. 3 square minus position is 2. So minus 2 square is omega into x value, which is 2. 3 square 9. 9 minus 4 is 5. So root 5 is equal to omega is 2 pi by time period into this 2. So this will become 4 pi by t, and this is root 5. But I don't want that. I want time period. Time period will be 4 pi by root 5. 4 pi by root 5 is there as Champa, Capto, whatever you want to call. C, option C. Yes, definitely. No, it's not B. Time period is mentioned, time is not mentioned. That's the reason why we did not use the other equation. We used these equations in terms of x, because this was exactly your x. This was basically your A. That's how you will understand which formula to use. Don't get scared. Sir, how did you realize? See, that's because of practice, nothing else. But when you solve more and more problems, you will get a hang of it. In fact, I would suggest solve the same problem after the class is over without seeing. Pause the video and solve the problem. If you are able to do it, that's it. Very good. Proud of you. If you are not able to, no problem. See first line or 2 lines. Don't see the entire solution. Okay? So that's what you can do after the class. Next one. NEET 2015. For a SHM, velocities at x1 and x2 are v1 and v2. What's the time period? Very nice question. Time period is asked. V is given, x is given. I can see square and roots. So immediately the thought process should be towards the other equation of velocity, which is none other than v is equal to omega root a square minus x square. But here v1, it is x1. For v1, the position is x1. Similarly, I can say for v2, omega root a square minus x2 square. Same omega, same amplitude. At this position, this is the speed. At that position, that is the speed. How do you find time period? To find the time period, I will somehow need omega, but amplitude is not needed. Amplitude is not needed. It is not even there in the options. I want to get rid of it. How do I say bye-bye to amplitude? You can't just say bye and go away. Let's just square this and see what do we get. V2 square is omega square a square minus omega square x2 square. I'm just squaring this equation, that's it, and I'm opening the brackets. Similarly over here, I'll get v1 square is omega square a square minus omega square x1 square. Now, are you able to think how do we get rid of A? Can we say tata bye-bye to A? Is there a way to say tata bye-bye? Yes, think about it. Is there a way to say tata bye-bye to A? This is equation 1. This is your equation number 2. I feel there is. Since these two terms are same, just subtract these two and see what do you get. Just subtract these two. Equation 1 minus equation 2. What will you get? You will get v1 square minus v2 square. Omega square a square and omega square a square will just get cancelled. That's it. This minus this will make it minus omega square x1 square, minus minus will make it plus omega square x2 square. Great. Omega square is common. So omega square x2 square minus x1 square. So therefore, from this, I will get the value of omega square. Omega square will be nothing but v1 square minus v2 square upon x2 square minus x1 square. But omega and time period, they are related. So that is 2 pi by t. If I take roots on both sides, it will be root of v1 square minus v2 square and x2 square minus x1 square. Now I want time period. Take time on the top, flip this and bring it here. So it will become 2 pi root x2 square minus x1 square by v1 square minus v2 square is nothing but your time period. Take time on the top, take the RHS on the left hand side. You will get the time period. That is it. Which option is it now? Yep, that is option number B. Very good. Excellent. So this was a very good question which was asked in NEET 2015. these years, last few years, they have been asking very lallu questions. So you can see the level of the questions was decent back then, but over the period of time, it has deteriorated and become much, much simpler. If you see 2020, 21, 22, 23 papers, like, oh my God, so lallu pallu. How many of you want those lallu pallu papers only this year? How many of you want it? Yes, 3 months is decently enough if you work very hard, otherwise it is not enough. So you have to work really hard for cracking NEET. Now let's go to spring mass system and pendulum systems. That's the last few things which are there in the chapter, apart from phase and phasors and all of that. So we'll see that as well. So ready for types of simple harmonic motion? There are two types of SHMs that we need to study. One is your spring mass systems. You take a mass, you elongate it, leave it, it will go back and forth because of the restoring force by the spring. The spring will pull it back. It's like a relationship. It's like a Pandu-Champa relationship, you know. The Champa is like the spring, Pandu is like that mass. Pandu tries to come very close to Champa, very, I don't know, very interested Pandu, I should say. He tries to come very close to Champa. When he comes very close to Champa, Champa is like, go away, stay away from me, what are you doing, why are you coming so close? So Champa says, go away. So Pandu gets sad, he goes away. And when Pandu goes away, Champa also feels sad. Champa is like, okay, please come back. So she brings him back, and then Pandu becomes happy, he comes very close. Again, when they come close, again they fight, and Champa is like, don't come so close, go away. So exactly the same thing is happening over here. So when the spring gets elongated, the mass is pulled back, and when the mass comes very close, the spring gets compressed, again the spring will push off that block. So it keeps on oscillating because of the restoring force. If you go away, it pulls it back. If you come too close, it pushes it away. So that's a primary reason for anything to go back and forth, oscillate. Only then it will oscillate. If the block said, okay, or the spring said, when I'm away, the spring says, hey, it's okay, you go away. That's it. The block will keep on going away, it will never return. It will not be an oscillatory motion. Or Pandu is coming very close to Champa, the block is coming very close to the spring is getting compressed, Pandu is coming very close to Champa, and Champa does not stop. Champa is like, it's okay, Pandu, come close, and they hug each other, that's it. So guys, that will not be an oscillation. Pandu is not going away, there is no fight happening. So for oscillation, there must be some kind of a restoring force. Do you guys agree? Yes. Awesomeness. So now the next one obviously is we'll see that it is going to be pendulum motion. Where is it? Angular SHM. We'll be seeing that also after some time. So angular SHM, meaning you twist something and there is a dance step. You do this, or in the exercise, when you are exercising, you do this step. How many of you do this kind of exercise? Or this, you do this. You do this, right? How many of you do this? This is angular. See, my angle is changing and it is oscillating. If you see, the angle is increasing, decreasing, 0, negative, 0, positive, 0, negative, 0, maximum positive, 0, maximum negative. It's changing. So that is angular SHM. Or I'm doing this exercise, right? This is positive, 0, negative, 0, positive, 0, negative. That is also angular SHM, or even a pendulum. It goes back and forth, positive angle, 0 angle, negative angle, 0 angle, positive angle, 0 angle, negative, positive, 0, negative, 0, positive, like that. So that is angular SHM. Yes, salsa dance step, says Deepthi. Everybody dancing? I hope, some parents will be like, what are you watching? You are watching some dance step. Why? You sit and study, What are you doing? What are you watching? Some dance step and all. Tell your parents, no, sir is only dancing. Sir is only dancing. It's not, I'm not watching something else. This is studies only. This is oscillation. Sir is oscillating. So I am watching sir dance over here. Okay. So very good. Awesome. That's the only kind of exercise I do. Sanvi, please do more, or else your body will become very stiff. You need to exercise, my dear students. You guys are going to be doctors. You are going to treat patients. You are going to give advices. Like doctor saying to a patient, hey, you don't don't smoke, please don't drink anything, don't do this, don't do that. And the doctor is only smoking, the doctor is only, no, you shouldn't do that. You should preach what you are practicing, right? If you are practicing something, then you should preach. If you're not practicing that and you are preaching, that's hypocrisy. Correct. Oh my God, Kavya, say sorry to your mom, okay? Sir is going to teach now. Show this lecture. Sir is going to teach. Okay. So, here, combination of springs. This is prior knowledge required before we go ahead. Springs in series. Let me just put a duplicate over here. Springs in series. Oops. K1, K2. So when they are in series, I can convert them into one single spring, Ks, where 1 by Ks is 1 by K1 plus 1 by K2. So this is when they are in series combination. The formula is of resistors in parallel, exactly opposite, okay? It's exactly opposite. So when they are in series, you can replace them as one single spring, and that is basically your formula for resistors in parallel. Similarly, let me tell you, if your springs are in parallel, if your springs are in parallel, something like this, this is K1, this is K2, you can replace them with one single spring. I will call it Kp. Here in this case they are in parallel, and that will be just K1 plus K2 will be the equivalent spring constant. K1 plus K2 plus K3 if there are more springs. As simple as that. As simple as that. Just to give you an example, let's see if you can do this. Find K equivalent. The springs are something like this. This is K, this is K, this is also K. Come on, what is the equivalent spring constant? Let's see if you guys can do this. Come on, come on, come on. Rachel, the weekly mock test 9 o'clock in the morning, victory mock test at 2 o'clock standard time, whatever was mentioned during the victory test, same time, okay? When I announce the victory mock test, same time, 2 o'clock to 5 o'clock, victory mock test. Weekly mock test based on the syllabus taught on YouTube is at 9 o'clock. And we listened to you because you guys were like, sir, we want weekly mock test also, sir, we are ready to put in the hard work. If I don't see students, you know, in the weekly mock test, then we'll be stopping it. I'm telling you now. Okay, so what is the answer, my dear warriors? Come on, think about it. First of all, these two are in parallel. When they are in parallel, you just add them, K plus K, which is equal to 2K. Now, you can say that 2K is in series with that K. So 1 by K equivalent is 1 by 2K plus 1 by K, which is 2K with 1 plus 2, which is 3 by 2K. So reverse it. So equivalent is 2K by 3. 2K by 3. Very good, very good, very good. Excellent. Now, there is also one more thing which you should know. When you cut a spring, those kind of questions are also very, very common. And basically, you know, you are cutting a spring. When you cut a spring, then each of those parts, the K value, let's say K prime, and if this is L prime, this is L double prime, each of their K's are inversely proportional to their lengths. K prime is inversely proportional to their length. K double prime of this spring is inversely proportional to that length. That's how it works. The spring constant is always inversely proportional to their lengths. So K prime by K double prime will be L double prime by L prime. And you know, L1 prime plus L double prime is the total length. That's how it will work, right? The total length of the spring will obviously be L prime plus L double prime. That's how it is. So each spring constant is inversely proportional to the length. That's something which you should know. So the spring constant is inversely proportional to the length. More the length, less the spring constant. Less the length, more the spring constant. More length, less spring. Less length, more spring. Okay, that's how it works. Keep these things in mind. In fact, there was a question which came in NEET 2017. Very interesting question. Observe it. A spring of constant K is cut into lengths 1, 2:3. They are connected back in series. New constant is K1. When they are connected in parallel, their new constant is K double prime. What is K prime by K double prime? Okay, I'll tell you what has happened. See, there was a long spring. There was a long spring like this. The original constant was K. Original length was L. Now what you do is you cut it into ratio of 1:2:3. Like that you cut it. So this is lengthwise 1:2:3 ratio. Each one of them will have some constants. Each one of them will have some constants. Let's say I call it K1, K2, K3. What will be their spring constants ratio? If length ratio is 1:3, 2:3, what will be their spring constant ratio inversely related to the length? So it will be 1/1. Then inversely related to the length is 2, so it will be 1/2. Inverse means reciprocal. Inversely related to the length, that means 1/3. So the K values are 1/1 is to 1/2 is to 1/3. You take the LCM. LCM is 6. LCM is 6. So it will be 6, right? You take the LCM is basically 6. You multiply by 6. You basically just multiply by 6 and see what you get. If you multiply by 6, 6/3 is 2. 6/2 is 3. 6/1 is just 6. So 6:3 is to 2. That is the value of the individual case. That is the value of the individual case. Everybody understood till this point? Everybody understood it till this point? Okay. What did you do now? What did you do now? Think about it. Since K and length are inversely related to each other, K and L are inversely related to each other. So my dear warriors, I think now you should have understood by now what are the individual springs constants. What are the individual springs constants? What is the individual spring constant of each one of them? What is the individual spring constant of each one of them? Come on, think about it. Come on, think about it. Yes, it will be just. Yes, the value of K1 will be basically 6K. The value of K2 will be basically 3K, and the value of K3 will be basically 2K. This is 6K, this is 3K, this is 2K. They are inversely related to each other. That's all. And all of them are in parallel. You can think of it like that. They are all in parallel like this. They are all in parallel. And when in parallel, how do you find the equivalent spring constant when in parallel? When they are in parallel, they are connected in parallel. What is the equivalent spring constant? Just add them. So it will be basically 6K plus 3K plus 2K. How much will it be? How much will it be, my dear warriors? Think about it. 6K plus 3K plus 2K. That is going to be 11K. Is that right? Will it be 11K, my dear warriors? Yes, perfecto, perfecto. So K double prime is 11K. Now, what about series? When they are in series, the force constant is K prime. Guys, if you connect it back, you will get back the original spring. So, when they are in series, you should get back the original spring constant. If you connect them in series, you find the total spring constant. You should get back the original one, which is K. So question was, what is K prime by K double prime? Question was, what is K prime by K double prime? K prime is K, K double prime is 11K, K cancels 1 by 11. So 1 by 11 was the answer, which is option B for Baswa sir. Biology, yes. Botany, perfect, perfect. Got it? Hello Homo sapien, welcome bacha, welcome dear. Yep. So what just happened is that you should use spring constant is inversely proportional to the length. So whatever length ratio, flip it, you will get the values of K, 6:3:2. So if this is 6K, this will be 3K, this will be 2K. 6K, 3K, 2K in parallel will make it 11K, just simple addition. When in series, if you combine them, you get back the original spring. You can see that, you just collect them together, it's the same thing. So original spring constant should be obtained. So K by 11K will be 1 by 11, that's all. Okay, that's what it is. Perfect. So this was angular SHM, which I told you just some time back. We are going to see that as well. Now, I was talking about two kinds of SHM. One is spring mass system, which happens along a line. So that's why it is also called as a linear SHM. The other kind of SHM is angle-wise, angular SHM. That's usually related to pendulums. Santhil, I'll be obviously teaching waves separately. Yes, I'll be teaching waves separately. Now, my dear students, whenever you have a spring mass system, the restoring force of a spring is given by minus kx. Is that right? F is minus kx. If you pull the spring, extend the spring by x amount, the force is opposite to x. That's why the minus sign. Otherwise, magnitude is kx. K is the spring constant. K is basically your spring constant. What will your acceleration be? Acceleration is force by mass. So it will be minus k by m into x. Acceleration is minus k by m into x. But, what is that but? But we know when a mass oscillates back and forth, the usual formula of acceleration that we have been using is minus omega square into x. What does this tell you, my dear warriors? Come on. What does this tell you, my dear warriors? Compare. A is minus k by mx, is minus omega square x. Obviously, it tells you omega square and k by m are actually the same thing. Isn't that right? So omega square is actually k by m, or rather omega is root k by m. A very important formula. Omega is root k by m. Wow, perfect. But I will not stop there. Omega is 2 pi by time period. That is equal to root k by m. Therefore, the time period, take that time period on the top, that will be 2 pi root m by k. 2 pi root m by k. A very important formula for finding the time period of a spring mass system. You tell me the mass, tell me the constant, I will tell you what time does it take to go back and forth. Thank you, Homo sapien. Thank you. Chala thanks, Homo sapien. Means a lot. Yep. Sir, when to use sine cos equation? Valhar, use it when, number one, time has to be found, or time is given, not time period, time. At this instant it was here. Where is it at this time? Then you use that sine cos equation. Otherwise, you don't have to use. Okay? Cool? All right. Now, let's see if you guys can solve this question. Look at these two springs. There is a mass and you move it back and forth. The question is, find the period of oscillations. Find the time period of oscillations. What do you think is the way to solve it? Try to read the question again and again. Try to read the question again and again. Come on. Yes. Naku Telugu telsu. Koncham. Yeah, not too much. Yes. Yeah. Koncham Telugu telsu. Yes. So come on, think about it. How do we solve this question? What do we do about this? Yep. So over here, these two springs are side by side. These two springs are side by side, and many people think that the springs are in series, right? But there is a catch in these kind of questions. I'll tell you what is the catch. You move this mass over here slightly. You move this mass over here slightly. The spring is getting compressed. This spring is getting compressed. This spring is getting elongated. You can see this spring is getting elongated. This spring is getting compressed. Compressed. This is getting elongated. Because of which, what will happen? This spring, because it is compressed, it will apply a force in this direction. And because this spring is elongated, it will pull in this direction. Don't you see the forces are in the same direction? Don't you see the forces are in the same direction? Awesome. Yes, very good. And I want all the students from Andhra and Telangana to be a part of the Vedantu NEET English channel, especially if you know your friends, in your communities, in your societies, in your groups. You need to tell them, see, Shreyas Sir is here. He is doing everything for all the South Indian students. So if you are a Telugu student, Tamil student, Kannada student, or Malayalam student, you should get all these students, and be a part of this channel. Because this is a channel which we started originally for all of us, right? Because not many channels are there for all of us on here, especially on YouTube, and especially you need good teachers. So most of the channels in English, either they didn't work well, or they are not teachers who are themselves from IITs or NITs. Most of the teachers you might not see that well qualified. So that's the reason we are here for you with the best of the best teachers. You should tell them. Okay, now over here, what you should do, you should realize that if both the springs were on the same side, and then also if you moved the block slightly here, slightly pushed the block here, then both the springs would be compressed. The force will be like this and like this only. Is there any difference between this force diagram and this force diagram? Nothing, right? Isn't it the same thing? Yes, Susanta, Northeast also. Yes, I have heard a lot about students from Assam, Manipur too, who are watching. I can see my channel analytics who are watching these sessions, and I'm really glad that you guys are here. So happy. Yes. So what do you see, guys? Aren't these two diagrams the same? What does it mean? It is definitely in parallel, and in parallel the equivalent spring constant will be just k plus k, which is basically 2k. So the time period, which is 2 pi under root mass, this will be equivalent k. So this will be 2 pi under root m by 2k. That is the answer. That is how you solve this exercise 13.6. Got it? Yes. Thank you, Krishna, so much. Thank you. It's very nice to see Sarath. You are from Kerala. I never knew this. Dina is from Andhra. Shivani is also from Andhra. Deepthi is also from Andhra. Nice to see you. Susanta, Ningatujam, thank you, my dear kids. Thank you. So let's move on to the next one coming up on your screen. Yeah, this was done. See, in NCERT solutions, if you look at the solution, no, you will pray to God. You will be like, what is this, God? Why such a lengthy solution? Shreyas Sir does it in such a simple manner. He just drew one diagram, another diagram. He understood it is in series. Tup, tup, tup. In 3 lines, we got the answer. What is this story? Something and all is there. That's what in boards, right? You need to write these stories. They love these stories for some reason. I think, they might be selling your answer books in that Raddi shop. They might be getting nice money for it. I once got to know that in one school, teacher used to scold students because you are writing very little answers, and when the teacher saw big answers, full booklets, very happy, and after the exam is over in summer holidays, nicely collect all the answer books on big heap, class 1, class 2, class 3, everyone. Nice. You sell it off, you get nice 1000 rupees full party only. I feel that's what I think board people will be doing. Imagine 30 lakh 20 lakh board students writing the exam each year. I can't even imagine the amount of answer sheets that would be generated over there, and that much amount of heap of paper, and imagine you sell that and you get a lot of money. Yeah, cool. I think I should look for a, we all should look for a job in CBSE just to sell those papers, hai na? Let's all apply, guys. Okay, what about this? This is also same problem. There is no difference whether it is like this, whether it is like this, whether it is like this. Sir is looking like sir is doing Kathakali only. No guys, I'm not doing Kathakali. So whether it is oscillating like this, whether it is oscillating like this, whether it is oscillating like this, it's one and the same thing. You are going to get the same answer. Time period is 2 pi under root m by what is this? Why is it this option marked? No, this was not the correct option. This should be the correct option. 2k. Okay, 2k should be there over here. 2 pi under root m by 2k. Understood, my dear warriors? Perfecto. Perfecto. It's the same thing. Doesn't matter at all. Moving on to the next, and that is energy in SHM. Any oscillating particle has elastic energy, and because it is in motion, it has kinetic energy. Both these energies combine together and you get the total mechanical energy. And this total mechanical energy can't go anywhere, can't be magically created or can't be destroyed. It is always conserved. So once you take a pendulum and leave it, it will keep on oscillating, assuming no air resistance. You take a mass, you pull it, the spring will keep on oscillating that mass. No place for the energy to go away unless there is friction or there is air resistance, which we usually ignore in our NEET, right? So there is no air resistance in NEET, there is no friction in most of the questions in NEET, right? Perfecto. Awesome. So what do you do in these things? How do you find out the energy? It's very straightforward. So let's start off with kinetic energy, which is half m v square, which is half m. Velocity is a okay, I can use this, omega root a square minus x square, right? Is that right? So this will make it half m omega square a square minus x square. M omega square, what is m omega square? Think about it. Okay, half m, omega is root k by m, omega is root k by m square into, my god, so many things, a square minus x square. When you square this, mm cancels, you will be left out with half k a square minus x square. Half k a square. This is kinetic energy. Don't get confused and say, sir, this k and this k will cancel. Let me write it properly. Kinetic energy, kinetic energy. So the kinetic energy came out to be half k a square minus x square. K is the spring constant there. Now let's also find the potential energy, my dear students. Half k x square is the spring potential energy, right? The spring or basically your elastic potential energy. Now you add both of them. What will you get? You will get the mechanical energy, which is kinetic energy plus the potential energy. This will be half k a square minus x square plus half k x square. Mechanical energy, I can just call it as E. X square cancel, half k a square remains, half k a square remains. So this becomes your formula for total mechanical energy. This is your total mechanical energy, and the total mechanical energy is directly proportional to the amplitude square. Not just that, you can see this will be always a constant with time. I mean, as time progresses, it is not going to change. It's going to be conserved. All right. If you don't want to use the word constant, I can say it is conserved. It is basically conserved. Okay. It will remain the same. Cool. If kinetic energy increases, potential energy decreases. Potential energy increases, kinetic energy decreases. They will add up, to be a constant. In fact, there is a graph for this, beautiful graph. You might have seen this many times even in work power energy. Yes, this graph you might have seen it in work power energy. Observe this carefully. As this yellow one is potential energy, the yellow one is potential energy. So potential energy is in yellow, which is half k x square. You can see it is a parabola, upward parabola. You can see that? Upward parabola. Yes, that is potential energy. Half k x square, quadratic equation. If you see kinetic energy, it is inverted parabola. Inverted, or I can say downward parabola. Downward parabola, the kinetic energy, because it is half k a square minus x square. The negative makes it downward parabola. If you see this one, that is the total energy. This one is the total energy. This is half k a square, and this you can see is constant. It's always constant. So when kinetic energy increases, potential energy decreases. So when potential energy increases, kinetic energy decreases. Kinetic is maximum at the origin or at the mean. At the extreme, potential energy is a maximum. Yep, perfect, awesome, cool. So let's go on to some more questions now. All these formulas are very, very important, whatever I gave over here, the energy analysis. A block mass 1 kg, spring has some constant, block is pulled by some distance from its equilibrium position, smooth surface is there at t is equal to 0. The kinetic energy, potential energy, total energy of block when it is 5 centimeters away from the mean position is how much? Okay, let's understand this question. This is your line. This is x equals to 0, which is your mean position. The block is pulled from x equals to 0, which is equilibrium, to x is equal to 10. This is x is equal to 10. Okay, and this is at rest, velocity is 0. And this is also at t is equal to 0. It is here. When you leave it from there, then obviously it will begin to accelerate. It will start going like this. And once it reaches here, it will have maximum speed. So that's how it is going to go, like that. Question is when it is 5 centimeters away from the mean position. 5 centimeters away from the mean position. So when x is equal to 5, what is the kinetic and potential energy? That's what the question is. Spring constant is given. So can we just quickly find the potential energy, which is half k x square, half spring constant 50, x is 5 centimeter, which is nothing but 5 into 10 to the power minus 2 whole square. So this will make it half into 5 into 5 square is 25. This 0, which is 10 raised to 1 into 10 raised to minus 4. So this will make it 125 by 2 into 10 to the power minus 3. Right? Everybody with me? So that is your potential energy. What about kinetic energy? Let's find that out also. For finding the kinetic energy, the formula that I can use is half k a square minus x square. K is standard, that is 50. Amplitude is exactly this, which is 10. Amplitude is basically 10. So 10 square minus 5 square, and this is all 10 to the power minus 2's square. 10 to the power minus 2's square, right? Because it is in centimeter converted into meters. Okay, so what am I getting over here? Kinetic energy will be half as it is, 5 as it is, that 10 to the power 1 as it is, into 10 square is 100. 100 minus 25 is 75. So into 75 into 10 to the power minus 4. Is that right? Everybody with me? Everybody with me? Getting it? Yes, where are all the people? Sleeping? Come on, everyone. Yes, very good. Now do the simple math. 75 into 5. Yeah, that's going to be 300. So this will be 300 by 2, which is 150. So 150, and this will be into 10 to the power minus 3. This will be again in joules. That is the answer. Just like this was also in joules. Cool. So that is kinetic energy. This is your potential energy. Cool, guys. Very, very good. Awesomeness. Awesomeness. Great. Great. Cool. Chalo, let's move on now to the next one coming up on your screen. A body is executing SHM with a frequency of n. The frequency of the potential energy is how much? Body is executing SHM with a frequency of n. What is the potential? What is the frequency of the potential energy? Okay, this is very, very straightforward. I'll tell you how. If a block goes here, comes back, goes to the other extreme and comes back, this is one oscillation. It takes one time period. But if you look at how the potential energy will change, observe what will happen. Potential energy will increase, increase, increase. Potential energy will increase. As you reach here, it will be maximum. Then it will become decrease, 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 become zero. Become zero. Excuse me. It will become zero till here. Again, it gets compressed. Potential energy increase, increase, increase. Maximum. And again decrease, decrease, decrease. And becomes zero. So this is one time period. Do you see that there are two oscillations in that same time period energy wise? This is potential energy wise, maximum, minimum, maximum, minimum. So 2 times faster. So 2 oscillations in the same time. This is one oscillation. So obviously the answer will be 2. This will be 2. Yes, Indira will be having everything. Don't worry, very soon. Yep, got it. B option, why it came. Moving on, next one. If the potential energy is 20 plus x minus 2 square. Looking at the question only, many people fainted. They're like, sir, what is this? My head is aching, sir. I'm sorry, sir. I'll faint. No, it is very lallu. I'll tell you how. If the total energy is 36, what is the maximum energy of the particle? One thing you should realize, the potential energy is not a standard equation like you have seen before. It is some weird equation. But one thing I know, potential energy will be minimum, then it will be maximum. Potential energy minimum, then it will be maximum. That at least I know. Agree with this? Okay. So what I will do, observe now. I know potential energy will be minimum and then maximum. So this will be U minimum. I know at the extreme points, the potential energy will be maximum. If you look at the equation of U also, it is 20 plus x minus 2 whole square. Now think, in this equation 20 can't change, x minus 2 can change. So x minus 2 can be 0 also, can be minus 1 also, minus 2 also, plus 3, plus 5, anything. When U is minimum, then won't this guy be 0? Because this is the least possible value that you can get. Think about it. The least possible value that you can get is when x is actually equal to 2. X is 2, the total value that you get is basically 0. Won't the potential energy be minimum and it will be just 20? Won't it be just 20? Think about it. This is 20 plus something, 20 plus something, 20 plus something. If that something only becomes 0, that will be the least value. And this value is always going to be positive because it is squared. Because it is squared, it will always be positive. It will never ever be negative. Oh, perfect. Now, also think, what will be the maximum value of the potential energy? I'm like, sir, it can be anything. No, it can't exceed the mechanical energy no matter what. The maximum value can't exceed the total energy. It has to be at some point the total energy. It can't exceed more than that. Oh, so the maximum is 36. The minimum is how much? It is 20. So now I know how the potential, if it is like this, the kinetic will be like this. So what is the maximum kinetic energy? Think about it. What is the maximum kinetic energy? So here the kinetic energy will be 0. Here the kinetic energy will be 0. Even here it will stop. So how much will be the max kinetic energy? The difference of the two, it will be 36 minus 20, which is 16 joules, which is C for Captain Shreyas. C for Captain Shreyas. Okay, it will not, don't say minimum kinetic energy will be 20. No, it stops at the extreme position. It will stop, right? If it stops, obviously kinetic energy will be 0. Obviously kinetic energy will be 0. So the difference will be the gain in the kinetic energy. It will be 16. Understood how we solved this question? What we did in this question? Okay. Otherwise, many people do some random things and complicate the scenario. Don't do that. It's very, very straightforward only. Moving on to the simple pendulum. Very, very simple questions come on this. Very standard questions come on this. A very, very popular thing. So again, you take a mass, you move it here and leave it. It will go back and forth and back and forth and back and forth. Now, usually whenever you are solving these angular motion problems, just like a mass when stretched because of the spring, it goes back and forth, and the time period for a spring mass system is 2 pi under root m by k. Similarly, what happens is you take a body and you twist that rod. You twist that rod, meaning you twist it like this, you rotate it, you rotate that rod, you twist that rod. Okay, it was supposed to be here, you twist it. Okay, I hope you are able to visualize this diagram. It's a little bit difficult to make you think about it, but I'm trying my best. It's like you are twisting that rod. So whatever has been attached over here, that also has moved by some amount. You twist it, you will see that thing will also oscillate. That thing will also oscillate back and forth, back and forth. So when you twist it, this rod has something called as the torsional constant, which is again very similar to K, called as kappa. Just like over here, the K value was obtained by F is equal to minus Kx. Same way, the torsional constant over here can be written down as torque is equal to minus torsional constant into theta. What is theta? Theta is basically how much did you twist it by. Torque is going to automatically come into play because it will be restoring in nature. That torque will be restoring torque in nature. So that torque brings you back. It is proportional to how much you twisted. That constant is called as torsional constant. The torsional, what is it called, my dear students? It is called torsional constant. Okay, what is the unit of this? Torque is in Newton meter, and if you divide theta, it will be per radian. Newton meter per radian, that is your torsional constant. Keep this in mind. Is this point very, very clear till this point, everyone? Very good. Thank you, Sarat, for all the love and all the hearts. Thank you, Shivani, for warming up the chat box. Thank you, Krishna, for the warrior Pandu's whistle podoing. And now, just like here, time period was 2 pi under root m by k. What do you think might come inside the root? Instead of k, you will have torsional constant. Instead of mass, you won't have mass here. Here you will have I, which is nothing but moment of inertia. That's all. That's the major difference in angular SHM versus linear SHM, nothing else. So time period is 2 pi under root. I by K. This is the main formula. Okay, so I'm just going to block this. I'm also going to block this. If you are able to prove torque is proportional to minus K theta, then time period is 2 pi under root moment of inertia by K. Right? Everybody? Yes. Yeah, when you squeeze water out of wet clothes, correct. Correct. Very good example. Very good example. You know, one more example. I used to do this when I was a kid, and I think I still do it. And sometimes when I see a nice, rocking, hanging chair, you sit on the chair and you turn yourself like this. Not 1 round, 2 rounds, 3, 4 rounds, and you leave your hands, leave your legs from the floor, and you sit back and relax. That thing will go like this. It will go like this. It will go here. Stop. Then it will go like this. Stop. Then it will go like this. Isn't it a torsional kind of pendulum? It will go like this, like this, like this, like this, like this, like this. Because of air resistance, it will finally stop. But if air resistance was not there, it will continuously oscillate here and there. Isn't it? How many of you have tried this? Raise your hand. Yes, so many of you would have tried this. So, one special case of this is your physical pendulum. In a physical pendulum, you have some body which is usually hanging like this. This is the pivot point. This is the pivot point. This is the center of mass of the body. The distance from pivot to the center of mass is basically D. Now what you do is you rotate the body. You basically rotate the body. Now the center of mass has come, let's say, over here. This is your whatever, that D, okay, distance between center of mass and the pivot point. So now the gravitational force which is there downwards will have two components. One component which is perpendicular, another component which is like this, another component which is like this. If I have turned it by a small angle, let's say I call that angle theta, let's say I call that angle small, some angle theta. I hope you are able to see that. Yes, not many, very few topics are left. Okay, so we are covering it as soon as possible. Within the next half an hour will be done, or 20 minutes I guess. Then the mg force which is there, because this will be theta, because this would be also theta, this would be theta obviously. So that's why this will be mg cos theta and this will be mg sin theta. Mg sin theta causes a torque. Mg cos is passing through the pivot, so this force does not cause any torque. Okay, it does not cause any torque. So the restoring torque due to a component of the weight, is given by torque is R cross F. Remember, this is perpendicular. R is D and F is mg sin theta, but it is opposite, so minus. Otherwise no need of minus, it's just restoring, that's why it is minus, restoring. But if theta is small, then instead of equal to, I can approximately say it is minus d mg into theta, because of small angle approximation. If theta is small, then sine of theta is approximately theta. That's the standard approximation. Great. Now you can see torque is proportional to minus theta. Torque is something into minus theta. So therefore I can immediately say this whole value is like your torsional constant. is like your torsional constant. So therefore, the time period will be 2 pi under root moment of inertia by k. K value will be d into m into g. I by dmg. That is the formula for a physical pendulum. Is that okay? Is that okay? Time period is 2 pi under root I by dmg. Very, very important formula. Not many people know about this. Not many people know about this. A best example for this one, a very good example for this one. Imagine I take a solid disc. Okay, it's a disc over here, and I hang it at this point. This is the pivot point. This is the pivot point, and I rotate the disc like this, and I let it oscillate. I let it oscillate. Question is, what is the time period of oscillation? That could be the question. Now, if you notice in that particular disc which is there, this is the pivot point. This is the pivot point. This is the center of mass. Naturally, the distance d over here is the radius. Okay, distance d over here is the radius. I also need to find the moment of inertia about this point. So to find the moment of inertia about the pivot point using parallel axis theorem, I will say it is ICOM plus md square. md square using parallel axis theorem. Parallel axis theorem. So ICOM for a disc is mr square by 2. D over here is r only. So it will be 3 by 2 mr square. So now let's find the time period. The time period of oscillation will be 2 pi under root I by d into m into g. So it will be nothing but, I just put it here down only. Yeah, it will be nothing but 2 pi under root. Instead of I, put it as 3 by 2 mr square. 3 by 2 mr square. D is r, m is m, g is g. You will see many things will get cancelled. RR, so 3R by 2G. So that is the time period of oscillation. Root of 3R by 2G, the whole thing into 2. Got it, everyone? Pivot is a joint which can allow the rotational motion. Yes, exactly. It's like your ball and socket joint. This is a pivot. This is a pivot. Even my elbow is like a pivot, right? It can rotate things about it. Yes. Okay, I hope this is clear. Susanta, hinge. A rod is hinged. A rod is pivoted. A seesaw is pivoted at the center. Pivoted means it is hinged over there. There is a joint over there. It allows the thing to rotate. That is the meaning of pivot. Okay, I hope this is clear. Okay, good. Thank God you are asking all the doubts and getting it cleared. Very, very proud of all of the NEET warriors on the Vedantu NEET English channel. Very good. Proud of all of you. Smash the like button for yourself, nobody else, at least for yourself. Okay. Now a special case of this is simple pendulum. I'll tell you how. In case of a simple pendulum, this is the pivot point, or basically the hinge point, whatever you want to call it. This is the pivot or the hinge. This is the length. This is a small mass. It's not a big thing like a disc, rod. No, it's a small point mass like a bob. That's a simple pendulum. Then when I try to find the time period using the same formula, time period is 2 pi under root I by dmg. Observe what will happen. Observe what will happen. Since it's a point mass, this is the point about which it rotates. Moment of inertia, I'll just use mr square formula. R over here is L. Just ml square. That's it. I mean, there is nothing great over there. The distance of the center of mass from the pivot is just going to be L. Okay, perfect. So here I'm just going to substitute these values. ml square, d is L, here lmg. So time period is 2 pi root, mm cancels, ll cancels, 2 pi root L by g. That is the formula. Time period is 2 pi under root L by g. L by g. Very, very useful. Remember a very important thing. Sometimes in accelerated in accelerated cabin or frames or basically elevators, these kind of question, the G is actually the effective gravity. The effective gravity. It's basically the combo of actual gravity because of Earth and the pseudo force gravity and the pseudo gravity. Because if you accelerate a lift up, you will feel that, oh my god, my weight has increased. So G will be G plus A. If the lift is falling down, you will feel little bit less weight. The acceleration due to gravity inside that lift will be G minus A. So you have to use the effective gravity inside that cabin or that elevator or that frame. Is that understood? Okay, right, perfect. Let's do some questions. I have put the table of difference between simple harmonic motion for linear motion, simple harmonic motion for angular motion. So angular and linear, both the differences are there. It is standard. I mean, there is nothing great. You can just have a look at it. Later on, it will be there in your notes. Okay, please go through this table. It will be useful in your boards if you are in 11th, or else it's okay. For NEET, you can just go through it once. What is the length of a pendulum which ticks seconds? Which ticks seconds, meaning what? Which ticks seconds, meaning the thing which got banned in India, what was it? Tick tock. This is the one. Tick tock. Tick is 1 second. Tock is also 1 second. So tick tock is how much? So tick tock is how much? 2 seconds. So basically we want a time period of 2 seconds. But we know the formula, that is 2 pi root L by G. That is 2. So 2 to cancel. So pi root L by G is equal to 1. Now you'll be like, sir, what to do next? Don't worry. Pi root G is equal to, root of L is equal to, root of G by pi. Now you know why I did this? You know why I did this? Yeah, it is an app. I know. I was chumma playing around. So, what is root of G? What is root of G? Actually, G value only is pi square, approximately. It's a very good approximation. So it will just become pi by pi. Pi by pi is 1. So root of L is 1. So L is 1. This is a very, very important approximation. This has come many times and you should know this. Pi square is approximately G, which is approximately 10, or which is approximately 9.8. A very valid and important approximation. I'm putting it over there. Excellent. Moving on to the next one on your screen. Simple pendulum is attached to the ceiling of a stationary life which has a time period of 1 second. I think, which life is there which has a time period of 1 second? I think it should be lift, no? Some spelling mistake, I think, over there. Don't get scared. So, which is that stationary life, sir, which has a time period of 1 second? Some next level thinking it will be. The distance y is given by this. If g is 10, the time period of the pendulum will be. Because it's in a lift which has some equation of motion, meaning it is having some acceleration. So definitely you have to use g effective in that. G effective in that case, it's a lift like this, and you can see the y value is changing. Y value is changing, and that's the reason why I can say it is accelerating upwards. So whatever pendulum is there inside which is oscillating, the time period for that will have 2 pi root L by G plus A. Because it's going up, you will feel more weight. Pseudo force is down. Agree? Pseudo force is down. Even the actual gravity is down. So pseudo and actual will add. It will add to the weight. So G plus A. How much is that A? Very simple. Dy by dt dy by dt is 3.75 derivative of t square with respect to time. So 3.75 into 2t. That is the dy by dt. Now, what is the next derivative? D square y by dt square will be 3.75 into 2 into derivative of t with respect to t. That's it. So that will be 3.75 into 2. How much will it come out to be? What is the value of acceleration that you are getting, my dear warriors? What is the value of acceleration that you are getting, my dear warriors? Come on, sleeping heads. Tell me, 7.5? Very good, very good, very good. So put it as 7.5. Put it as 7.5 meters per second square. Awesome. This is your acceleration. Now substitute that here and you will get the answer. So this will be nothing but 2 pi root of length. Length is... It has a time period of 1 second. It had a time period of 1 second initially. So we can do one thing. 1 second was 2 pi root of L by G. So if I divide this with this, if I divide this with this, I'll get T by 1, 2 pi gone, L gone, root of G will be there, here G plus A will be there. So that will be root of 10 plus 7.5 by 10. So time period will be root of 17.5 divided by 10, which is root of 1.75. That is the value of the time period, root of 1.75. Got it? Got it, everyone? Paka? Awesome. So if you take root of 1.75, approximately how much will it come out to be? I think it will come very close to 2 seconds. Approximately it will come very close to 2 seconds. Okay, when you do that, just see. No, I think something went wrong somewhere. Something went wrong somewhere. Just see. 3.75 into 2, 7.5. Oh, my bad, guys. It was moving down. It was not moving up. I'm so sorry. The whole problem, whatever I solved, I didn't look at it. I thought it was moving up. So it was supposed to move down. I'll just rewrite it over here. So this was supposed to go down. This was supposed to go down. So this will not be plus. This will be minus. So sorry. So this will be G minus A. G minus A. Okay. So G minus A everywhere. G minus A everywhere. So G minus A. Right. So this will be 10 minus 7.5. How much is it? It's 2.5. 2.5 by 10, which is basically 0.25. Just check this out. Just check this. I think here also we made a mistake. Just 1 second. Let me just do one more time. Let's just do this one more time so that we don't do any mistakes. Okay. So over here, basically this lift, it is moving down. It's moving down. So it is accelerating down. This is the acceleration from some point. This is the y value, which is given to be 3.75 t square. So the pendulum which is there over here, when it oscillates, the time period of that pendulum will be 2 pi root L by the effective G. Because it is going down, that's why you will feel little bit less weight. So it should be G minus A. When it was stationary, the time period was 1 second. So when it was stationary, time period was 1 second and the gravity would have been just G. Now if you notice, I just have to divide these two. So T by 1 will be root of, T will have G minus A over here, one will have root g on the top. So this will be nothing but 10 by g minus a, which is 10 minus the acceleration. How do you find the acceleration? Well, from here, velocity will be dy by dt. So that will be 3.75 into 2t, which is basically your 7.5t is your velocity. What will be the acceleration? That will be derivative of the velocity. So when you take the derivative of 7.5t, it will be 7.5 into 1. So acceleration will be 7.5 meters per second square. So subtract 7.5 over here. So what are you left with is root of 10 by 2.5. Is that right? So that will be root of 4. So time will be 2 seconds. So you should get the time value as 2 seconds, which is D for yes. D for doctor. Is that okay, everyone? Yep. Very nice question. Lift is going up or down, we need to be careful. And if it is going down, G minus A. If it is going up, G plus A. That's it. Great. Let's go to one more question. This was asked in NEET 2022. Two pendulums of these lengths are in phase. That means in the same situation. Because their lengths are different, one will take longer, one will take shorter time to complete, and they will keep oscillating like this. And after some time, you will see, after few oscillations, you will see that both of them will eventually come in the same phase, and again they will have some difference. Okay, and eventually you will see again after some time, again they will be in the same phase, and then again the difference will start popping up. So after how many vibrations or oscillations the shorter pendulum are again back to the same phase? That's the question. All right, so here is what we do. Time period of the first pendulum is 2 pi root 121 by g. 2 pi by root g, I'll keep it as it is. Root 121 is 11. So this I will put it as some constant. I can call this as k. So this I will just call it as 11k. T1 is 11k, where k is this value. What is k? What is k? This whole value. This whole value is basically k. Similarly, if you do the same math for the other guy of 100 centimeter, it will be 2 pi root 100 by g. So 2 pi root g as it is into root 100 is basically 10. So T2 will be, because 2 pi by root g is k, it will be 10k. It will be basically 10k. Now think, T1 is 11k, T2 is 10k. T1 is 11k, T2 is 10k. So I'll make you visualize this. If T1 is 11k, this is 11k, and they both start at the same time. They both start at the same time. T2 is 10k, slightly smaller. I hope you can see that. When you put one more oscillation over here on this map, this will be 11k like this, but that 10k and 10k will make it only till here. So see, 10k, 10k, you can see the gap widening. They started at the same time, because the lengths are different. One is falling behind the other, and more oscillations will make it fall even more behind and behind. So my dear students, you wait one more time period, again it will fall back even more behind. This is like your vernier caliper, something like your vernier caliper. After some divisions it coincides, right? Something like the vernier caliper concept only. So think about it. Eventually you will see that this will coincide. Eventually you will see that this will coincide with this, and that's when I would say they are back in the same phase. That's when I'll say they are back in the same phase. So how many oscillations of this and how many oscillations of this? Obviously for this guy you would need only 10 oscillations, and for this guy you would need 11 oscillations, because the LCM of 10 and 11, come on my dear warrior, says 110. So 11k, 10 times, 10k, 11 times. So this one is 11 times and this one is 10 number of times. So the shorter one 11 times, the longer one 10 times. Understood, my dear warriors? Understood, my dear warriors? Clearo? Very good, very good, very good. Yes, perfect, Sarath. Awesomeness. Where is it? Option B. So this has come in NEET 2022. Now let's go to the, I think, final part, which is SHM as a projection of circular motion. This is going to blow your mind. Okay, very, very important. Very, very important part. And after this, yeah, this chapter is almost going to be over. So what is this SHM as a, projection of circular motion and all of that? See, just think about it. If there is a line over here, and I'll tell you, your only job is to drop a perpendicular on the line wherever that point is. To drop a perpendicular on the line wherever the point is. Let's say the point is here, the point is over here. You drop a perpendicular. You see, the perpendicular meets that line over here. After some time, this point, let's say, reaches here. Your job is only to draw a perpendicular. So you draw a perpendicular reaches here. After some time, that point reaches here. Your job is only to drop a perpendicular. So you drop a perpendicular on this gray line. It is over here. After some more time, the point just reaches over here. Your job was only to drop a perpendicular and you saw that it is over here. After some more time, you see that this point reaches here and your job was only to drop a perpendicular, so it is here. After some more time, you are here. Your job since was only to draw a perpendicular, it was here. After some more time, you are here. Since your job was only to draw a perpendicular, you are here. Now look at that orange point. What is it trying to do? That orange point is basically going in a circle. That orange point is basically going in a circle, isn't it? That orange point is basically going in a circle. How many of you are able to see that? How many of you are able to see that? That orange point is basically going in a circular motion, in a uniform circular motion. Everybody? What is that yellow point doing? See, when this line was here, it was here. Then it came here. Then it came here. Then it came here. Then when it reached here, it came here. Then it came here. Then it came here. Then it came here. So it is going back and forth. So it is just going back and forth. That's all it is doing. That's all it is doing. Nothing else. It's just going here. It's just coming back, going here and coming back. That's all. No other job. This is your origin. So isn't that part nothing but a simple harmonic motion, oscillatory motion? Isn't this part nothing but an oscillatory motion, my dear warriors? So when I drop a perpendicular, I'm taking a component on the axis. Sometimes it is also called the shadow of the point. As if the sun was here, the shadow will fall here. Sometimes it is also called the projection, meaning if light rays were coming from here or from here, the projection, if it is like this, then the shadow of that point will fall over here. So projection, component, shadow all mean the same thing. So the projection of UCM is a SHM. The projection of UCM is a SHM. Is this point very, very clear? Is this point very, very clear? So the projection of a UCM, what is it? It is a simple harmonic motion. If you don't like that word projection, you can also call it as the shadow, or you can also call it as the component. You can also call it as the component of a UCM. Of this UCM, it's a X component or Y component, whatever you want to call it. It's all meaning the same thing. So let's understand and prove it in a little bit better manner. It will be very, very useful for all of us. So let's take let's take a nice circle over here. Okay, and let's draw, oops, okay, let's draw a horizontal line, which we often call it as the reference line. Reference line. Okay. Okay, then we just create a duplicate. Okay, perfect. And then imagine we show from the origin the particle is over here and it is going like this with some angular velocity omega, UCM, right? It is performing UCM like this. Over here, it's performing uniform circular motion like this. Initially, it made an angle phi. After some time of reaching here, at some time, this was here initially, t is equal to 0. This was here initially, understand that. After some time, t, right, it would have moved some angle. How much angle will it move? How much angle do you think it will move? It will be nothing but omega into t. Angular speed into time is the angle displaced. Radians per second into second is the radians displaced. So the total angle with the reference is phi plus omega t. Everybody with me? Is phi plus omega t. Next thing what I'm going to do is drop a perpendicular. And just join this point till this point. And I know this is a beautiful right angle triangle, and this particular length I'm just going to call it as x. The radius of the circle I'm just going to label it as a. I hope you can see that beautiful triangle which is formed. right over there. The hypotenuse is a. The base is basically x, and this total angle is omega t. I'll just put it over here. Is basically omega t plus phi, right? That is what that angle is. So what will x be? My dear warriors? The value of x will be nothing but a cos omega t plus phi. Perfect. We have showed that it is a SHM. We have just showed that it is a SHM. What a lovely thing. Thank you, Total Joy. Thank you so much. The mascot is here. Yep. And Candy, the next chapter will be on Monday. Okay? The next chapter will be on Monday. Beautiful. So we have proved that it is a SHM. That means as that point moves, you will see the particle goes like this. The SHM will be back and forth. So this particle does uniform circular motion. This particle does horizontal motion. Beautiful. Right? This is what you can do. Now it also makes sense that wherever the particle is initially, the angle made with the reference line is called as the phase constant. Oh, so that phase constant, remember initial phase, is actually the angle made by the position of the particle with the reference line. That is what that phi actually represents. Similarly, my dear students, over here, if similarly I show the reference from here, and let's say the particle was here initially at t is equal to 0, and this is basically phi. After some time it reaches here at some instant of time. This was at t is equal to 0. Remember, this is my reference line. Then again when I drop again when I see how much has it moved, it will be omega t. This is the angle displaced. Radians per second into second is radians. How much angle I have moved. Now what I will do, again on this particular line, I will drop a perpendicular. Observe. Oops. I will drop a perpendicular like this, and I will measure the base over here. This will be basically your x, this will be 90 degree. Observe carefully, the base is x, there is a perpendicular here, and this beautiful triangle is formed. Guess what this angle is? This hypotenuse is A. This is the radius of the circle, which is going to be A. What is this angle going to be? You can see two parallel lines. You can see one intercept. I hope you can see that. Yes, this is one intercept, one parallel line, one parallel line. This total angle is omega t plus phi. Even this angle must be omega t plus phi. This is omega t plus phi. This is also omega t plus phi. That's what you should be able to see. So this will be omega t plus phi. So again, you will see over here, x is a sine omega t plus phi. X is a sine omega t plus phi. Isn't that so? Very good, very good, very good. Awesomeness. So again, it is a projection of SHM only. Again, sorry, projection of UCM only. SHM is the projection of UCM. Point is, whenever you are taking a sine graph, take the reference here. Keep that in mind. Whenever you are taking a cosine graph, take the reference from here. That's all you should keep in mind. Cos graph, take the reference here, measure it like this. Sine graph, take the reference like this, measure it like this. Okay, it will go like that. This will be how the angular speed will be. Now, let me tell you, my dear students, whatever I have drawn has a name associated with it. It has a name associated with it. I'll tell you what is the name and everything. Oops. Yes, let me just draw a few things and then I'm done over here. Yes. Okay. So this angle phi in uniform circular motion, this angle phi, what is it called? It is your initial angular position. Initial angular position. You move more omega t. So phi plus omega t or omega t plus phi becomes your final or current angular position. Current angular position in uniform circular motion, that is. Is that right? This is in uniform circular motion. This is what you are going to tell. Now, this A which is there, is the radius of the circle. The omega which is there, that is basically called as your angular speed of the uniform circular motion. But when you look at simple harmonic motion, the same symbols are called differently. The same symbols mean differently. Like in the school, you might be roll number 55, but at home, you are maybe Chintu, but for your friends, maybe you are Pandu. So you are the same person, has different meanings and different perceptions. What is this phi in SHM called? It is called as the phase constant. This is called as the phase constant. What is omega t plus phi called? It is just called as the phase of the SHM. What is A called? It is called as the amplitude, my dear students. And what is omega called? It is not called angular speed. It is called angular frequency. Angular frequency. Is that right? Very good. Very good. Excellente. What is this diagram called which represents that particular particle performing SHM? This diagram is basically called as the phasor diagram. This is called as the phasor diagram. This is your phasor. Strictly speaking, this is the phasor which is rotating. This is the phasor diagram. It tells you about the phase or the situational diagram. It tells you where is the particle in circular motion. That's what it represents. So if I ask you what is the length of the phasor, answer will be A. So this is also basically the length of the phasor. This is the length of the phasor. This is the length of the phasor. This itself is called as the phasor. This diagram is called phasor diagram. This length is called length of the phasor. This omega is the speed of the phasor. Is the speed of the phasor, or rather the angular speed of the phasor. Understood, my dear warriors? What is a phasor diagram? What does it mean? Yep, clearo? Awesome, awesome. Keep this in mind. So a phasor diagram, is it a real diagram? No, it is just a representation. Like for example, we all know that we live on Earth. We all know we live on Earth. There are continents, right? There are continents, there are islands, there is ocean, everything is there on Earth. But what do? We show it on a map, right? We show it on a map. We show it on a map. We show it on a map, right? Something like this, right? We show it on a map. Does that mean that there is some place like that map where you can walk and you can see India, you can see China, you can see Nepal, you can see US? No. Is there something which is labeled Indian Ocean in reality? No. This is a map view of the real world. Or you can have Google Maps of the real world, like you have the atlas of the real world. Same way, understand, SHM is for real. Actually, a particle will go back and forth. You can imagine, you can picturize a circular motion corresponding to the SHM. This is the circular motion. This is the simple harmonic motion. That circular motion is representing some characteristics like phi, omega t plus phi, a and omega, which helps us analyze the problem a little bit better. That's all. Is that clear, my dear warriors? Yes. Yes, very good. Very good. Keep it up. Keep it up. Now, if there are two or more SHMs, imagine one particle is performing SHM like this. This is SHM1. Another particle is also oscillating back and forth, SHM2. Then each of the SHM may have their own individual phasor. Let's say this is A1, which is going like this, and maybe another one has amplitude A2 going like this. When you merge them together, when you put them together, then it might look like this. This is A1, this is A2. Both of them are rotating together with some speed, and you can see that there is some difference between them. That is called delta phi, which is your phase difference. Phase difference, very, very important. Phase difference, the difference of the phase. Both the SHMs are not moving together. One is like this, one is like this. Can you see one is following the other? One is always ahead, one is behind, something like this. Sometimes the phase could be much larger, something like this. Something like this. If they are going together, then they are in the same phase. They are moving together. Sometimes they might be one behind the other. So their phasor diagram will also have two circular motions which are moving one behind the other. So there is a difference of the phase. That is your phase difference, which is simply put the modulus of phi 1 minus phi 2. Phase constants difference is the phase difference. Is that clear? Yep, very good. Now, why is this phase difference so important? Why is this phase difference So important. It's important for combining SHMs, meaning imagine that you have a Pandu. What is this Pandu's job? The Pandu's job is to go front and back. Front and back. That is Pandu's job. That is Pandu's job. Okay? So that is Pandu's job. He has to just go front and back. And then Pandu is asked, okay, listen, you hold one plank. You hold one nice plank over your head like this. He is going 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 like this and like this. He is going like that. And on his head, who is there? Champa is there. Champa is there. Do you see beautiful Champa over here? Champa is also going back and forth like this. Champa is going on that platform back and forth. She's walking like this, like this, like this, like this, like this, like this. Now imagine the platform is also moving. Champa is also moving. Isn't it combination of SHMs? Isn't it combination of SHMs, my dear warriors? Yes or no? Yes or no? Very good, very good, very good. Excellent day. So you combine the motion together. You combine the motion together. And when you just see Champa, imagine, see, Pandu is bearing Champa's weight, but you are outside. This is you now. This is you. You are standing on the ground and you see a Champa. You are not looking at Pandu, the platform. You are not interested in Pandu. You are just looking at Champa. Wow, Champa is looking so beautiful. She is going back and forth. So you will see Champa. You will see Champa performing something called as the resultant of the two SHMs. Which are the SHMs? These are the two SHMs. SHM1 and this is your SHM2. SHM2. So what are you doing? You are resultant of the two SHMs which are superimposed. Which are imposed. What is the meaning of the word superimposed? You are adding Pandu's effects also and Champa's effects also. You want both the effects together. That is meaning of superimposed. That is the meaning of superimposed. You want both of these effects together. Sometimes you get one scolding from mom and scolding from your dad. Both the scoldings get superimposed and you get nicely bashed. You are very, very sad that they demotivated that day. Same thing. Both the effects of the SHMs are superimposed. That's why you get resultant SHM. Understood? Everybody with me? Okay. Okay. Very good. Very good. So, whenever you have to add such SHMs, you know what you should do? Just, you might be wondering, sir, what is the use of phasor diagram? It's basically for this only. You take SHM1, show that phasor 1. Take the SHM2, show the other phasor number 2. And both of them will not be in the same direction. There will be some phase difference between them. Treat them like vectors and see how I have arranged them one vector after the other. I am trying to use triangle law and I will just draw the missing side. I'll just draw the missing side. That's it. That is the resultant phasor. So the resultant phasor is vector addition of the individual phasors. The resultant motion can be represented by a resultant phasor, which is vector addition of individual phasors. So you can just write this. AR vector is nothing but A1 vector plus A2 vector. So strictly speaking, the magnitude of AR is root of A1 square plus A2 square plus 2A1 A2 cos del phi. This is the formula. This is the formula for finding the resultant of the phasors. For finding the resultant of the phasors. Isn't it amazing? You can use these concepts for combining two SHMs together. for combining these two SHMs together. Usually you don't see questions in SHM, you will see the application of this in waves, light waves, sound waves and waves on a string. That's where you'll be seeing the main applications. So main thing you should realize, even in AC, alternating current, you'll be seeing this. Main thing you should realize, whenever you have SHM, you can think of a visualization which is called as a phasor, whose speed is omega, whose length is a, and the diagram is called phasor diagram. It just tells some qualities of the SHM. That phasor can be often treated like a vector in many situations, and you can add and subtract them like vectors, just like over here, like finding the difference between them or just adding them, superimposing them together to make it the phasor diagram. Got it, my dear warriors? All right, so it's time we wind up as well now. Yes, it's done. So yes, please remember that there is a mock test which is going to happen this Sunday. One is at 9 o'clock. This is your weekly mock test. But there is also a victory mock test if you are a part of the victory batch. Yes, then the victory mock test is going to happen at 2 o'clock. It's going to happen at 2 o'clock. Okay. The weekly mock test is going to happen at 9 o'clock. The syllabus is exactly whatever we have done in the weekly mock test in this particular week. In the victory mock test, if you are a part of it, you can always scan the QR code and you can always see the schedule and the upcoming syllabus of those tests in that particular test series itself. So make sure you are giving these tests, or else if you don't give these tests, then we'll understand you are not interested or serious about NEET. Okay. And please join the Telegram channel, because the PDF will be shared on the Telegram channel. Be a part of it right now. You can also download the PDF of today's session in the Telegram channel itself. Okay, be a part of it. Okay, don't go anywhere. And I want everyone to put up in the comments that you have oscillated. I want to see this word oscillated in the comment section. That way I'll understand, yes, these are the students who have watched these classes completely. Okay, smash the like button, subscribe the channel as well, so that you do not miss any further updates and further lectures. Okay, splendid class. We took help of Pandu and Champa to understand many concepts. The last few concepts, you will see particular applications are there in waves. We'll be coming to that in a separate chapter. But main thing is finding time periods, looking at simple pendulum, spring mass systems, and obviously velocity, acceleration, position, those sine cos equations. Those are the main things of this chapter. Okay. So all the best. This chapter will definitely give you 4 marks minimum, and it can give you anywhere up to 12 marks. Yeah, anywhere up to 12 marks. Keep that in mind. So have a great time. Have a great weekend. See you again very soon. Bye bye. Take care. Captain Shreyas signing off. Hasta la vista.